I'll start now.
Okay, a very good morning to all our participants, ladies and gentlemen. Welcome to the MPOC-Swinburne Palm Oil Educational Outreach Webinar. Our guests of honor will be arriving shortly. Before the webinar starts, there are a few housekeeping rules and announcements to take note of. For the best experience, please ensure you have a good internet connection and that your microphone is on mute. The formal part of our webinar today consists of 5 presentation sessions by distinguished speakers and a forum on careers in the palm oil industry, as well as future research prospects. We will then be ending the day on a more lighthearted note with a Kahoot quiz and a lucky draw. With that, do stay until the end and you may walk away with a prize. I will now briefly share a few guidelines regarding the quiz. Only student participants are entitled to participate in a pop quiz held via Kahoot. The login URL is www.kahoot.it. You can participate via your preferred mobile device. Before the game starts, participants will key in their game PIN shared on the screen and register their email address together with their nickname to enter the game. The questions and answer options will be displayed on both the screen as well as on the participant's device for your easy viewing. Participants will have to answer all questions within the allocated time. Your active participation will be rewarded as we have many prizes lined up. For Kahoot quiz, the first place is an RM300 ringgit worth of Zalora e-gift card. Second place is an RM150 worth of Zalora e-gift card. And in third place, it'll be a 75 ringgit worth of Zalora e-gift card. For the fourth and fifth places, they will each win an RM50 GrabFood e-gift card. There are also 25 consolation prizes up for grabs, which is an RM20 GrabFood voucher, bringing it to a total of 30 winners for the Kahoot quiz. A friendly tip for you, do pay attention to the presentation as it may help you to answer the questions. But if you didn't win any of these prizes, don't worry as there will be a lucky draw session right after. The lucky draw session is open to everyone here today, not just the students. The organizing committee will review the participants' lucky draw numbers on the screen, so do watch out for your name. The lucky draw winners will be announced one by one as the draw numbers appear on screen. A total of 10 lucky draw winners will each win an RM30 GrabFood e-gift card. Throughout the talks, you're welcome to post your questions to the respective speakers in the Q&A chat box to interact with them. Please do take this opportunity to ask the experts as many questions as possible. An e-certificate will be awarded to all participants who have attended this webinar. Please do fill out the feedback form provided at the end. Thank you for your attention. The webinar will begin in a short while. For those just joining us, a very warm welcome, and do have a look at today's program, which will be shown on loop.
All right, ladies and gentlemen, we shall kickstart with today's webinar. A very good morning to everyone. I'm Dr. Tan Sian Woon, and earlier on together with me here today is Miss Diana Chu, and we are your MCs for today's MPOC-Swinburne Palm Oil Educational Outreach Webinar, a collaboration between Malaysian Palm Oil Council and Swinburne University of Technology, Sarawak campus. Before we proceed further, please join me in giving your warmest welcome to our honorable guests. First up, we have Dr. Ruslan Abdullah, the Director of Science, Environment and Sustainability Division from the Palm Oil Council, MPOC. Next, we have IR Professor Lau Hieng Ho, the Pro Vice Chancellor, the Chief Executive Officer of Swinburne University of Technology Sarawak campus. And also our 4 guest speakers today, Dr. Sen Nathan, Dr. Lee Chin Mei, Professor Dr. Lam On Lun, and Dr. Siti Rama Haji Abdul Hafiz. Welcome. To begin with our occasion today, I would first invite IR Professor Lau Keng Ho, the PVC and CEO of Swinburne University of Technology Sarawak campus, to deliver his opening remarks. Welcome, IR Prof. Lau. Whenever you are ready, the floor is yours.
Good morning. Thank you again, Dr. Tang, and also Miss Diane. And good morning to all the speakers and participants. Ladies and gentlemen, thank you to each and every one of you for being here with us today. I'm very pleased to be able to welcome you to the educational outreach program on palm oil for territorial university students. This program is hosted collaboratively between Swinburne University of Technology Sarawak campus and also Malaysia Palm Oil Council. The program holds an important missions to increase the knowledge and understanding of the young adult in higher education institutions on the benefits and related issues on palm oil. We have 5 experts today coming from Sabah Wildlife Departments, University Malaya Pahang, University of Nottingham, Malaysia, Malaysian Palm Oil Board, and Malaysian Palm Oil Council. I'm sure the presentations later will be eye-opening and inspiring. Hopefully, what you heard and what you have seen today may influence your future decisions and perceptions on the consumptions of palm oil. Furthermore, I would like to express my sincere appreciation to the organizing team, including staff and students from Swinburne University of Technology Sarawak campus and working partners from MPOC. These events will never come together to become a success without your contributions. Thank you. Well, I don't want to take too much of your time today. I believe today's event will be fun and full of learning. To all the 500 plus participants of the quiz competitions, wish you all the best. Thank you and enjoy your webinar today.
Thank you, IR Prof. Lau. Thank you for your opening remarks. All right, ladies and gentlemen, I will now pass the floor back to Diana to kick off the first highlight of our occasion today, the presentation session. Over to you, Diana.
Thank you, Dr. Tan. Now is the time we've been waiting for, the presentations. A gentle reminder to all our distinguished speakers, you have 20 minutes for your presentation. Ladies and gentlemen, we will now proceed with our first presentation entitled Conservative Efforts in East Malaysia, which will be delivered by Dr. Sen Nathan from Sabah Wildlife Department. Before the talk begins, allow me to introduce the speaker. Dr. Sen Nathan is a veterinarian, a UPM graduate. He is presently based in Kota Kinabalu as the SWD's Assistant Director, where he oversees SWD's various conservation programs, such as the Borneo Rhino Sanctuary, the Borneo Elephant Sanctuary, and the Sabah Wildlife Rescue Unit. He will very soon be heading the Orangutan and Elephant Survey Project in Sabah. Without further ado, I would like to welcome our first speaker, Dr. Sen Nathan, to begin his presentation. Dr. Nathan, just a gentle reminder, you have 20 minutes for your presentation. The floor is now yours.
Thank you, Diana. Sorry, I had some issues coming into the meeting. So forgive me for being slightly late. Can everyone see my screen?
Yes, we can.
Okay, just give me a minute. Yeah. All right. Very good morning. Thank you to the Malaysian Palm Oil Council and for inviting me to present on your occasion today. My name is Dr. Sen, just call me Sen. I'll be presenting to you basically wildlife conservation efforts in managing human-wildlife conflicts in Sabah, or otherwise known as East Malaysia. Now, Sabah is probably one of the luckiest states in Malaysia, It's blessed for its fauna and flora. It boasts more than 200 species of mammals and around 540 species of birds, 197 species of reptiles, and more than 98 species of amphibians. This rich biodiversity contributes immensely towards Sabah's economic development. Ecotourism, bushmeat, edible birds' nests, both from caves and man-made nesting houses, contributed more than R500 million to the state's GDP in 2015. Now, a little bit about the Sabah Wildlife Department, the local wildlife authority which manages wildlife in Sabah. It was officially established in 1988 under the Ministry of Tourism, Culture and Environment. Prior to 1988, Sabah Wildlife Department was actually just a small games unit under the Forestry Department. But seeing the importance of wildlife conservation and wildlife management, the Sabah government at that time decided to upgrade the games unit into a fully fledged department. Now, this department ensures wildlife, caves, and protected areas in Sabah are managed and administrated by enforcing the Wildlife Conservation Enactment 1997. Now, our department strives to preserve Sabah's fauna, to ensure that every species remain in their natural habitat, and manage wildlife resources in order to maximize its role in the socio-economic development of the people in Sabah. Its headquarters is located in Kota Kinabalu, and it has numbers of districts and offices and centers and smaller stations all across Sabah. Now, I'd like to talk to you about the mainstay of my presentation, which is the Wildlife Rescue Unit. Yeah? Now, the Wildlife Rescue Unit was successfully formed in May 2010. The increasing human-wildlife conflicts and conservation issues in Sabah was what instigated the idea of setting up this unit under the Wildlife Department. Together with then Dr. Laurentius Nayan Ambu and myself, we actually brought this idea up to the Ministry of Tourism. Unfortunately, it was not approved due to insufficient government funding. However, searching high and low for funding from external sources, our efforts were not in vain, as we successfully managed to get in touch with the palm oil industry through the Malaysian Palm Oil Council, and to throw their weight and support behind this new unit. And that was more than enough to get this unit up and running. Now, Malaysian Palm Oil Council has been the mainstay, one of our main funders for the good work that the WRU does. And we have, since 2010, we have also had some other organizations that have chipped in and come in to assist us. Between 2010 and 2015, we had Shangri-La Surasaria Resort that was also giving us funds for the rescue works that we were doing. From 2019 till today, we are working very closely with UK-based NGO, the Orangutan Appeal. And in fact, one of their maiden funding for Wildlife Rescue Unit was funding 3 new vehicles, 4-wheel drives, for the rescue and translocation work that we have done. Oregon Zoo, which is an American zoo, has also stepped up to the plate and has been working very closely with WRU and Sabah Wildlife Department. They are primarily funding and supporting the work that we do with our Bornean elephants. As of 2020, mid-2020, there was the Malaysian Palm Oil Green Conservation Foundation that was formed. And I think what has happened, the Malaysian Palm Oil Council has, in a way, handed over the responsibility to MPOC-GCF to assist the Wildlife Rescue Unit in its funding capacity. But I'm safe to say that both MPOC, Malaysian Palm Oil Green Conservation Fund, are both in a way still assisting us in our fundings of the work that we do. Now, I'd like you to say hello to the team. It basically consists of 30 local Sabahan rangers from all around Sabah. And we have 5 veterinarians from all around Malaysia. I have to say it is really a one Malaysia team, not only racially, not only religiously, but really in every walks of life, especially our rangers. They're coming, bear in mind, they're coming from every nook and cranny of Sabah, and most of them, all of them are from small villages across the state. And you know, most of their moms and dads are probably uncles, were probably hunters at one time. So it's very interesting to see now that their children or their grandchildren are working to save wildlife in Sabah. Now, Wildlife Rescue Unit's main role is to assist the Sabah Wildlife Department in any conflict and conservation issues with its own staff. The unit is also responsible for other activities, including conducting wildlife rescue and translocation operations throughout the state of Sabah. Occasionally, the team also assists wildlife research programs and other conservation activities carried out in Sabah Wildlife Department or with its partners. Now, besides putting their backs into rescuing wildlife in the field, Wildlife Rescue Unit also prioritized the importance of wildlife conservation and promotion in terms of public awareness among Sabahans, as well as carrying out wildlife enforcement and monitoring operations in an effort to reduce incidents of human-wildlife conflicts all across Sabah. Now, if you look at this graph, this is a very interesting graph, right? Since the birth of Wildlife Rescue Unit, the total number of operation handles by the team has increased tremendously. So the issue with human-wildlife conflicts, enforcement issues has actually increased in time. During the first year of its entanglement with wildlife, that was in 2010, we only had 53 operations, which includes animal control, rescue, translocation, enforcement, post-mortem, and even other conservation activities. Now, these numbers has skyrocketed to 350 in 2020. Bear with us, 2020, 2021 were COVID-19 years. So, you know, when the whole world, including Malaysia, was in lockdown, the Wildlife Rescue Unit team was actually still there, day and night, working towards wildlife, towards protecting wildlife in Sabah. In fact, we were considered wildlife frontliners in Sabah, and we were one of the first batch, even in the wildlife department, to be fully vaccinated. Because our work took us everywhere in Sabah, into the plantations, into the villages. So again, I like to thank also the Ministry of Health and the Department of Health in Sabah for acknowledging Wildlife Rescue Unit's importance as frontliners and getting us protected, vaccinated for our work. Now, just to give you a snapshot of type of operation that is attended by Wildlife Rescue Unit in 2020, you look, big bulk of it was on rescues, 42%. Next would be wildlife controls. And then you have a smaller pieces of pies, which were translocation operations, enforcement, post-mortem, recce, and others. Now, in terms of cases that we have attended, okay, this is again a very interesting note to see. In 2010, one of the core activities or justification of setting this up was to look at orangutan and Bornean elephant rescue, translocation, and conservation work. So very true enough, between 2010 and 2015, our bread and butter was basically orangutan translocations and Bornean elephant work. But times change during the past 10, 12 years. The conservation efforts to look into orangutans habitat has actually improved so much, in fact, to a point that problems of issues with translocation and rescues orangutans are going down because more area which are orangutan habitat being protected. Same goes with Bornean elephant. Having said that, though, we still do have conflicts In fact, conflict with Bornean elephants are also in the increase, which I hope we can talk about it later. But other species has come into play. Macaques, which is not only a problem in the forests or in the villages, it's also an urban problem. Issues with crocodiles, which I'll talk to you later. But this again is a snapshot, of total number of cases based on species attended by Wildlife Rescue Unit in 2020. So again, just to give you a little bit of insight about the work that we do, human-wildlife conflict rescue and translocation still remains one of our biggest issues or efforts, conservation efforts that we have, and we work very closely with plantation industry. You know, I've been working with wildlife for the past 25 years, and you know, if you ask me 25 years ago, ladies and gentlemen, what was it like working with the palm oil industry? My answer is very challenging. There were many cowboys at that time, but I'm very, very happy to say that I think, you know, there's been a paradigm shift in the industry. I think they are more and more aware how important wildlife is to not just Malaysia, but probably to the world. And you can see the care and the passion that they have to actually, you know, protect wildlife, even wildlife that enters their plantation. This is a photo of some of our most challenging work, which is rescue and translocating wild elephants in Sabah. As you can see, we have issues with elephants that tend to prefer to stay in human habitat or agriculture habitat more than the forests. We have in Sabah, we look at coexistence as a priority, but there will come times when some of these elephant herds do overstay their stay in these areas, and they are causing some risk to human life and also to crops that are planted by villagers. So this is where we come in, and we actually need to translocate these elephants. So first thing you do when you go into when you're looking for an elephant and you need to dart an elephant, first of all, you need to find a big tree and make sure that big tree is between you and the elephant before you dart it. That's sometimes is a difference between life and death. And yeah, we've had our fair shares of life and death experiences being chased by elephants in the forest and plantation while darting them. As you can see this photo, this guy had a lucky break. This elephant was actually already sent to its translocation location. It was released, but instead of going into the forest, he decided to play cat and mouse with one of my rangers. Lucky for my ranger, those who have been to Sabah know this guy's name is JB. He's one of the most experienced guys working with elephants. Lucky he found a tree and he actually jumped on the tree. I don't have the photos of him jumping on the tree, but trust me, if the tree wasn't there, this elephant would have got him. Yeah? Now, the process of translocating elephants is not as easy as I'm saying. It's a long process. It uses a lot of heavy machinery. It costs a lot, but it's something that's very important that we do as the last ditch measure. If this elephant decides to stay in the agriculture area or human dwelling and doesn't want to go back into the forest, and sometimes it happens. As I said, it's quite expensive. It costs around 25 to 30,000 ringgit. As you can see, because it takes a lot of manpower, a lot of heavy machinery to transport them. Here we see some photos of also elephant calves that we have rescued. On your right, you can see myself. This is an elephant that had just been drugged or tranquilized or darted by myself in a FELDA scheme. And this is some of the SOPs that we do. As soon as we translocate, we give them an IV drip so they don't dehydrate. And these elephants are then, after 1 or 2 days, they are then translocated to a safer place in the forest reserve. Yeah, but you know, shit does happen. We have also have quite a number of elephant deaths now in Sabah. Here you can see on your bottom right, these are snare trap wounds. And these snares are actually placed by villagers, irresponsible villagers, and sometimes by also plantation workers, not in the plantation, but in the forest fringe. No, they are not hunting elephants, But what happens? These elephants are innocent bystanders. The leg gets trapped in the snare trap. They manage to escape, but the snare remains on the hand and remains on the limbs and causes strangulation effects. And we have to come in. We need to remove that snare, and we need to do medical intervention to make it to correct the problem. Sometimes we also have cases where elephants have been shot. They are not killed immediately, but they are injured. And these poor elephants do walk around injured, unable to eat in the forest. The picture on the top right basically shows a photo of an elephant that we tried to rescue. If you look at the body condition, it's severely bad. And then for this particular animal, I think the decision was made to euthanize because the wounds that it had was too much to bear. Okay, orangutans, like I said, we have some very good news for orangutans. These photos were taken about 4 or 5 years ago. The photo with me, this elephant, as you can see, I still have hair in my head. So this means this is at least 6 years old photo. Top right corner, you can see this was very recent. This made global news, where in fact this is in Sapilok. We had one of our rangers testing positive for COVID-19, so we did not want to take the risk with our orangutans, as orangutans are very closely related to humans. So we made a decision to actually do a full COVID test for all the captive orangutans in Sabah. And it's actually, I think, the first time anywhere in Malaysia, and I think anywhere in the world, that COVID-19 tests were done on orangutans. A few months earlier, there were COVID tests done on gorillas in San Diego Zoo, and a few months later, I think there was some tigers and lions in a zoo in US that actually got positive for COVID-19. So we don't take risks with orangutans. So we were happy to say that none of the orangs contracted COVID-19, and they are still monitored right now as we speak. So besides orangutans and elephant, proboscis monkeys are also some of the work that we do. As you can see, proboscis monkeys' habitat is in mangrove forests. Mangrove forests, because it's also one of the fastest growing deforestation areas. Not palm oil, but more towards agro-fisheries industry and even human population. We do see a reduction in some of the proboscis monkey population, and here is where we actually do rescue and translocation operations as well. Besides the orangutans, besides the proboscis monkey, the Bornean gibbon is another primate that we actually work quite a lot with. This is basically in the illegal wildlife trade. We have quite a number of cases of baby gibbons being kept illegally. In Sabah, you cannot keep gibbons as pets. It's against the law. So some of these babies are then brought into captivity, and our vets and our rangers actually hand raise these gibbons. Here you can see one of our vets, Dr. Paki. This was about probably 6 years ago. Actually handling one of the very recently rescued gibbons that was confiscated from the illegal pet trade. Macaques. Now, this is one of the biggest challenges now that we have. In the past 10 years, the number of human macaque conflicts, the whole of Sabah has increased geometrically. It's a huge problem. I do believe in West Malaysia, in West Malaysia, you also have a huge human macaque conflict. But the difference between West Malaysia and here, we do not euthanize any of these macaques. None of them are euthanized. So what we do, we actually capture or rescue them from these conflict areas. We have a holding area that we keep them. They're tested for TB. They're tested for other communicable diseases such as hepatitis. We have cases where macaques are positive for TB, and only during these circumstances, when the macaques are positive for TB, then do we euthanize. but more than 90% of these macaques are brought and released in virgin areas, in a sense, virgin areas where there are no macaques. Macaques being very industrial animals, they will tend to survive very well anyway. And you can see this lovely photo of these two macaques jumping for freedom, frozen in a photograph. I just like this photo very much. Okay, crocodiles, another big issue which is coming up also, believe it or not, in the urban jungle. 10 years ago, Wildlife Rescue Unit was really looking at work in the forest, in the plantation, but it has expanded to work in the cities, looking at crocodiles. No, these are not boya darats, though it's found in the cities. These are real saltwater crocodiles. We have a big problem with the increase of the crocodile population, and all these photos that are taken were actually taken in suburban and suburban areas. In fact, just yesterday, we just also rescued a crocodile from a village that was actually, believe it or not, attacking their chickens and even their goats. And in fact, one of the crocodiles had actually eaten one of their goats. So we managed to rescue this crocodile, and we have it in our holding area, and we will be releasing it somewhere further into the forest. Biggest challenge that we have now, because crocodiles are territorial animals, we can't just release them and forget about them. If that area has crocs, we can't release it. So another issue that we are having now is there is a possibility that we might need to, the crocodiles that are in the human crocodile conflict areas, we might need to put them in captivity. So that's something that we are looking at into. Again, we don't euthanize. We try not to euthanize any of our rescued animals if possible. Monitor lizards, same issue with crocs. Also something that is increasing leaps and bounds, and their sizes seem to be bigger, getting bigger by the year. This photo, if you can see, this bottom left photo was actually taken in one of our minister's house. I don't want to mention which minister, but some monitor lizards was extracted to this minister's house. Don't ask me why. So we actually had to went there and catch these buggers. Other species that we deal with, snakes is another thing. All our wildlife rescue rangers has been trained in-house on managing and handling poisonous snakes. They are experts, and Dr. Roslan, you'll be happy to know that the Wildlife Rescue Unit team that's funded by MPOC is, I would say, the team in terms of dealing with poisonous snakes in Sabah, handling poisonous snakes in Sabah. Marine wildlife, turtles are also some of the animals that we have to deal with. Recently, I'm sure you heard the news where 11 turtle carcasses were found eviscerated, and unfortunately, we were not able to catch the perpetrators. Also, issues with turtles swallowing plastic material. Rescued turtles that come to us, we don't have a very high success rate in releasing them back into the wild, because most of them end up not being able to eat, unable to dive due to floater syndrome. And upon post-mortem, we see 90% or at least 70% of these turtles that have these issues of floater syndrome have ingested plastic. So this is, again, it's a big issue. We have had some success stories though. Recently, we had one turtle that we managed to remove the plastic material, not from the upper end, but from the lower end, and it managed to survive, and we released this turtle. So besides turtle, dolphins, pilot whales, beach pilot whales are also a big issue that we have. Here, we are working with University in Malaysia, Sabah. They have a marine research center, so we work closely with them. Here is a pilot whale that we rescued. It was doing really well for a week or two, and then suddenly the animal died. And when the post-mortem was done, we found 15 kilos of plastic bags inside. ranging from detergent bags, from normal supermarket bags, and even we believe some of these bags originated from neighboring countries because it was not in Bahasa Malaysia. The writings on it was not in Bahasa Malaysia. So it's sad to see how plastic has caused a lot of issues with wildlife. Pangolins, the world's most illegally traded species, is an animal that we also work a lot with. We have a lot of awareness work that we do, and through awareness, in fact, a lot of villagers have come to us and said, look, we know this person is keeping a pangolin, so we go and we confiscate it with, of course, the Sabah Wildlife Department enforcement team. We do a medical examination and we release these pangolins. It's a very nice feeling, when we know that these pangolins that were destined to be eaten, to be in a pot or whatever, managed to be rescued. Vet checks are done and are released back into the wild. Other species that we work with is, the slow loris birds and whatnot. And you'll be surprised, we also work with we are also called to assist in rescuing or catching domestic species. This particular case was about 3 years ago. This was during a Hari Raya Korban, when one of the kerbaus that wanted to be slaughtered escaped, and we had to actually chase this kerbau across some of the suburban areas, manage to dart it, catch it, and bring it back to its owners. With dogs and cats, times when we have time, we also assist the local SPCA in assisting in rescuing these stray dogs and stray cats. But I have to emphasize, we don't do it all the time. We let them know that this is something that is not part of our job, but we assist when we can assist. Now, research, wildlife research work is also something that we do in tandem with the department and also other NGOs. Here you can see one of our rangers putting a camera trap to monitor wildlife. Over here, the other 3 photos, you can see our team assisting in capture of these elephants and satellite collaring these elephants. So their movements and their landscape movements and also their home ranges can be analyzed and monitored. As I said earlier, monitoring is also a big thing that we do. We do a lot of, not monitoring, awareness, public awareness. We are a hit when it comes to the school. The school loves us. They think that we're sort of like wildlife commandos with our black uniforms. Sometimes what we do, we have elephant skulls, crocodile skulls. We put it out there for the children to see, and they love it. They love us. And in fact, this is something that, if not for COVID, these past 2 years, we haven't had much wildlife awareness in schools, but we hope with next year COVID situation going down, we hope to continue this wildlife awareness program that we do. We do it together with other NGOs and also with the other departments as well. Now, these are 2 programs which is also funded by Malaysian Palm Oil, which again was delayed due to COVID, which is the orangutan and elephant survey that was supposed to start mid-2020, and also a planting of napier grass in wildlife corridors for elephants. So this is 2 programs that we are going to start in 2020. Fingers crossed, let's hope this whole COVID-19 is behind us. Things are getting better. Let's hope for no more outbreaks. Everyone adheres to SOPs, and hopefully 2022 COVID-19 just dies. It just goes running towards the sunset or whatever and leaves us humans alone. All right, with that, I'd like to say thank you to everyone. Sorry I took probably 10 minutes more than my time. I hope you guys don't mind. That's all I like to say. Thank you.
Thank you very much, Dr. San Nathan, for the thought-provoking talk. It is definitely important to protect, preserve, and manage multiple levels of natural resources to ensure that our future generations can enjoy our natural world as well. I hope everyone managed to gain insights to the conservation efforts here in East Malaysia. A reminder to all participants, please do post your questions to the respective speakers in the Q&A chat box to interact with them. Your questions will be addressed throughout the webinar and also in the forum session afterwards. Passing the floor now to you, Dr. Tan.
Thank you, Diana, and thank you, Dr. Sanathan. Distinguished audiences, now we have Dr. Lee Chin Mei from University Malaysia Pahang as our second speaker. Dr. Lee holds a doctorate degree from the University of Cambridge, and she is currently a senior lecturer at the Faculty of Industrial Sciences and Technology, University Malaysia Pahang. She has 15 years of experience in industrial microbiology, with her research focusing on development of microbial consortium for the sustainable management of agricultural waste. For today's session, she will be sharing a topic entitled From Waste to Gold, Generating Green Energy from Pomade. Without any further delay, I'll pass the floor to Dr. Lee. Dr. Lee, a gentle reminder that you have 20 minutes for your presentation. The floor is yours.
Thank you. Thank you for the kind introduction. And thank you for having me. So let me share my PowerPoint. So can you see my PowerPoint now?
Yes, Dr. Lee, we can see your PowerPoint slide.
Thank you.
But it's not projected as slide mode yet.
Okay, so let me try again.
Yeah. Oh, yes, we can see your slide.
Is it? Okay, thank you.
Yeah.
Okay, so my sharing today will be focusing on the biogas generations from the palm oil mill effluents. So let's start with the oil palm history in Malaysia. So the oil palm is originated from the Africa, and it was brought to Malaya in 1875 by the British government as the ornamental plant. It was then planted commercially in 1917 in Batang Berjentai, Selangor, by a French entrepreneur. And in 1956, the government has launched the FELDA scheme to eradicate poverty and also to develop the rural area. And since then, the palm oil has been planted in large scale in Malaysia. And now, oil palm is planted on 4.2 million hectares, which is 13% of the total land of Malaysia. So the palm oil certainly play an important role in our daily life. We are not only using the palm oil as the cooking oil, but the oleochemicals that have been processed from the palm oil can be found in many of the products in our daily life. So for example, the shampoo, the toothpaste, the pet food, the cosmetics, in your ice cream sauces, in the laundry detergent, as well as the household cleaning products. So the palm oil is the most widely used vegetable in the world. A matured palm tree can be productive for 25 years, and it produces 40 kg of oil in a year. And the fruits contain 30 to 35% of oil. And the oil palm is the most efficient oil crop in which that it produces a lot of oil in relative to the land use. And of course, it has lots of economic contributions. The palm oil industry is one of the most important industry in Malaysia, which has created a lot of work opportunity. So Malaysia now is the second largest producer of palm oil. That is the 39% of the world palm oil productions. However, the world palm oil demand has dropped significantly due to the recent decision of the European Commissions to classify the palm oil as unsustainable. So in a lot of the European country, the subsidy has been pulled out to use the palm oil as the biodiesel. And the main issue is that with the deforestation and the global warming. So to address this issue, the Malaysian Sustainable Palm Oil Standard has been made mandatory by the end of 2019. And one of the sustainable initiatives is to reduce the carbon footprint or the greenhouse gases emission during the palm oil production. So let's look at the waste. The palm oil mill effluents is the wastewater generated from the sterilization and the extraction processing in the palm oil mill. And to generate 1 ton of the palm oil, 5 to 7.5 tons of the water has to be used, and 50% of this water are actually discharged as the pomade. So the pomade is rich in the biodegradable constituent, and therefore they are high in the biochemical oxygen demand and the chemical oxygen demand. So if this pomade are being discharged untreated, it can pollute the water sources and it can deplete the oxygen in the river or the pond, and the aquatic organism will not be survived. And treating this wastewater would release the biogas. The biogas from the pomade consists of the 50 to 70%, 75% of the methane, and this is a really potent greenhouse gases, 21 times more powerful than the carbon dioxide. So it can actually trap a lot of heat and contributing to the global warming. So to reduce the adverse effect to the environment, capturing and converting the biogas to renewable energy is one of the alternative ways that can be utilized for the palm oil mills. So if you look at the biogas, it is generated by the microorganism during the breakdown of the organic materials from the pomade. And the main constituent of the biogas is methane, carbon dioxide, water, and low amount of oxygen, nitrogen, hydrogen sulfide, ammonia, and hydrogen. So these methane, they are potential renewable energy to replace our dependency for the fossil fuel. So in terms of the palm oil mill, we can replace the burning of palm oil kernel, shell, and the mesocarp fiber to produce the thermal energy in the industrial boiler. And the palm oil mill, they can sell the palm kernel shell and the mesocarp fiber and to generate income. Or they could use the methane as the fuel to generate electricity by the gas engine, and this will reduce their electricity bill. If the palm oil mill have generated surplus of the electricity, they can actually sell the electricity to the national grid, to the TMB, and there's a program called the feed-in tariff, which enables us to sell the electricity or the renewable energy to the national grid. So let's look at the biotransmission of pomade to the biogas. So first is the hydrolysis part. So the organic material in the pomade, the fats and proteins, carbohydrate is being transformed by the hydrolytic bacteria to a simple molecule that's the fatty acid, amino acids, and sugar. And the next phase will be acidification, that is by the acinogenic bacteria. And the simple molecule is being converted to the short chain organic acid and alcohol. And the third phase is the acetic acid formation, that is by the acetogenic bacteria, and the acetic acid, carbon dioxide, and hydrogen is being generated. And the last phase is the methane formation, and this is by the metagenic bacteria, and the biogas, the methane, carbon dioxide, and the hydrogen sulfide is being produced. So let's look at some of the example of the hydrolytic bacteria. That's the Clostridium, Bacillus, Staphylococcus, and for acidogenic bacteria, E. coli, some Staphylococcus, Pseudomonas, Bacillus, desulfovibrio, and the Clostridium. For acetogenic bacteria, some Clostridium, Cytrophomonas species, and the last one is the methanogenic bacteria. So they are mainly archaea. They are the methanobacterium, methanoplanus, and the methanobacterium, methanococcus. So to generate the biogas, normally it happens in the biodigester. So the covered lagoon is one of the most commonly used digester in the palm oil mill. So this is the biogas plant by the Green Initiative Mine Hijau. This is actually situated very near to the University Malaysia Pahang. So this is a huge plant, and normally the pomade is being treated in an open pond system, and therefore it's relatively easy to install a membrane on top of the pond and to capture the biogas. And later on, the biogas can be used by the boiler or the gas engine. And this, if you look at this, is the medium size of the covered lagoon. So this is normally found in the palm oil mill. So this is the other type, the continuous still tank reactor. So this is being made by concrete or metal cylinder, and the content inside this reactor is constantly mixing. So it can be mixed by mechanical, by using an impeller, or by using water, hydraulic power, or the air pump. So this kind of reactor actually generated less biogas because of the short retention time. So the retention time is about 40 days in contrast to the covered lagoon, which is about 60 days. So next, let's look at the biogas plant's component. So the pomade will be discharged from the palm oil mill, and then you have to go through some pre-treatment, and normally it's really hot, and it has to be cooled down, and some of the bigger objects have to be removed at this stage. And then the pomade can be fed into the biodigester, for example, the covered lagoon, and the microorganism will actually degrade the organic matter to produce biogas here. And normally, to treat the pomade at this stage is by the anaerobic process, and this is not enough to bring down the COD and BOD, and it has to go through aerobic digestion. So the pomade will be transferred into this sedimentation pond to further bring down the COD and BOD. So in this pond, the sludge will be also separated from the effluents. And in some of the palm oil mill, they use this sludge as the fertilizer in their plantation. And once the effluents have reached the standard to be discharged, and they can be discharged to the water source. And the biogas generated from the digester has to go through some pre-treatment before they can be used as the fuel by the boiler or the gas engine. So that the hydrogen sulfate being produced by the microorganism. So the biogas scrubber need to be installed to remove of the hydrogen sulfide, or else it will erode the engines. And the water also being produced by the microorganism, and this will actually affect the combusting of the methane in the boiler, and therefore the water has also to be removed, and then the biogas can be used by the boiler and the engine to produce electricity or to boil the water for the extraction of the palm oil. So the biogas looks like a really promising renewable energy, but however, only 35% of the palm oil mill has been installed with the biogas plant. And the challenges is that the investment cost is always high in the beginning, and the investor, they won't actually see the return immediately. And of course, this is not their primary line of business. A lot of the palm oil mill, they would like to actually expand their business to extract more palm oil rather than to produce biogas. And the lack of know-how with the regard of the operations of the biogas plants, and this process to generate biogas from the pomade is actually a complicated process. Lots of the parameters have to be taken care, and to make sure the successful of the generation, a lot of the parameters have to be taken care, and therefore probably the palm oil mill, they do not see really rewarding generation of biogas from this biogas plant. So that's all for my sharing. Thank you very much.
Thank you, Dr. Lee. Thank you for an enlightening talk on extracting value from pomade for renewable energy in the form of biogas. It is great to learn that it's not only supporting the local palm oil industry by creating a new economic value chain, but also protecting the environment and ensuring the whole palm oil industry remains sustainable. Thank you, Dr. Lee. Again, a gentle reminder to all participants, please do pause your questions in the Q&A chat box. Your questions will be addressed by our speakers later in the live Q&A and forum session. On to you now, Diana, for the next speaker.
Thank you, Dr. Tan. Respected audience, our third speaker for today will be Professor Dr. Lam Hon Lung. Professor Dr. Lam is a professor of Green Operational Management from the Department of Chemical and Environmental Engineering, University of Nottingham, Malaysia campus. He holds the director position at the Center of Excellence for Green Technology in the same university. Professor Dr. Lam received his first PhD in chemical engineering in 2010 from the University of Maribor, Slovenia, and his second PhD in information technology the following year from the University of Pannonia, Hungary. Professor Lam's research focuses on computer-aided chemical engineering for the palm oil industry, such as process integration, biomass network, and green supply chain synthesis. Professor Lam has an extensive publication record, as he has more than 200 publications in the form of journals, conference papers, and book chapters. In addition, he also serves as an international editor for several journals on Elsevier and Springer. Without further ado, I would like to welcome Professor Dr. Lam for his talk entitled Palm Biomass Supply Chain. Professor Dr. Lam, a gentle reminder that you have 20 minutes for your presentation. The floor is now yours.
Thank you, Diana. Thank you, MPOC, for inviting me. So I try to, I have difficulty to start my slideshow. Hey. Dear organizer, can you see my slide in the presentation mode?
Yes, we can.
Okay, thank you very much. Again, I'm Lam from University of Nottingham. I understand that today the lesson is for the students. So I try to keep my slide easier and mainly to raise the awareness to the student. What can we do with the palm oil biomass? Okay, so let's start with the introductions. How much palm oil industry can contribute, okay, to Malaysia? My answer is a lot, because palm oil industry is the biggest industry in Malaysia. It's covered the whole states, the area of the nations with the palm oil. Therefore, palm oil is very important to Malaysia. Okay, if we go to the next slide, then we can see how much biomass that we can harvest in Malaysia. I tell you, all students, I'm not sure if all students see the volume of 1 ton. Okay, 1 ton means 1,000 kilo. Okay, so that I want students to imagine 1 kilo is how big. And you know that biomass is very low density, means it's very bulky, means 1 kilo of the biomass is a lot. It's 1,000 kilo means a lot. It's 1 million thousand means a lot. Yeah, very, until that you can't imagine. But you look at the whole Malaysia, this is a map that the biomass that we can harvest. So if we add up together, I tell you, in Malaysia, we are the heaven of the biomass if we know how to use it. I believe you follow Dr. Lee just now that we can convert the biomass to very useful energy, green energy. And beside that, we have a lot of other technology that we can harvest. Okay, behind the biomass, we can harvest a lot of useful chemicals, useful green energies, and so on. Okay, so I would like to raise the attention to the all participants, especially our students here. Okay, please, biomass in Malaysia is the future for us if we are in engineering field and in the science and technology, because we are full of biomass in Malaysia, and we are so easily to access to the biomass that available in Malaysia. And this is a one stone kill two birds, mean at the same time you solve the environmental problem that we do not have so much of the waste, and then you convert the waste to the gold, as Dr. Lee said just now, and then you harvest the gold. You see, in one hand, you solve the problem of the waste, in another hand, you get the gold. So this is the future for us that we involve in engineering and technology. We focus on the biomass from the palm industry. Okay, first of all, we have the frond. Okay, the frond is a very good biomass, because the frond, I'm not sure if you believe me or not, but if they have a chance, okay, you try to bite the frond, because the frond is full of sugar. Okay, mean as scientist background, then you should understand if you have a lot of sugar, mean you can convert it to a lot of useful chemical. Yeah, sugar is very easily to be converted to another chemicals. Yeah, and then we have the trunk, we have the empty fruit branch. Okay, that hold the fruits. Okay, in the palm oil industry, in the mill, then normally we will steam the whole fruit. Then the fruit will go to the oil extraction, and then the branch like this. Yeah, the third one, then you will see is the empty one. So it's a very good biomass to us, and we have a lot, yeah, every day by day from the palm oil mill. And then we have the shell from the kernel. Then we have the fiber, mesocap fiber, for example. And last but not least, of course, we have the pomade that highlighted by Dr. Lee just now. Okay, so typically, I mean, I would say all technology, basically we will physically process the biomass. For example, from this slide, you can see we can make it become a fiber. After that, we can pack it, become a pellet, and then we will sell it to overseas as a very good burning material. Okay, as a part of the green resources. Beside that, you know, it's a waste if we just do the physical treatment to our biomass, which is a lot of value behind it. We call value change. Okay, so should we increase or enhance the value chains of the biomass from the palm oil industry? Answer is yes. Then we have to properly study the biomass supply chain. Okay, from here, again, I already show you there's a potential of the biomass from the empty fruit branch, you know, the palm kernel shell, so on and so forth. And then from the center, then you can see, okay, we have a lot of available technology from this part. Okay, for example, we have the pelletizing, we have combustions, we have fermentations. Okay, all these technology will convert to different products that suit to different purposes. For example, we have pellet, okay, briquettes. Okay, all these two is a very good burning material. We have the dry long fiber. Okay, this one student might not know what is this. I tell you, actually, under our tilam, okay, or sofa, actually the firm part, actually we are using this fiber to make it very firm. On top of that, only we put the latex. This combination will make the mattress, everything feel very good. Okay, this is why this can sell a very good price. Then we have the charcoal from the PKS, we have ethanol, we have electricity, we have heat, and so on. Yeah, all those are the product, that final product that we can harvest from the biomass. So this is why we call from the waste, okay, to the wealth. Okay, so we want to convert the W to W, from the waste to the wealth. So we go to the next. So this will be a proper, when we talk about the supply chain, then we cannot do like this. Yeah? We are engineers or we are scientists. So this diagram is for the boss to see, or for the investor. Do you want to invest? So as a scientific background, so we have to slightly change it to something that we call flow diagram. So from this flow diagram, what my research group doing is, we have biomass, we listed out all the biomass. Then we will put the, we will see, okay, the pathway. For example, empty fruit bun can go to combustions, okay, can go to pyrolysis, gasifier, and so on. Okay, this is something like McDonald's, okay, mix and match. Yeah, we do mix and match here, and then go into the different technology. Okay, I take one example. Okay, empty fruit branch can go to, one of the option is go to combustions. This combustion will produce a high pressure steam. Okay, and this high pressure steam will go to steam turbine, okay, to produce the electricity power, as well as a medium pressure steam. And this medium pressure steam can link to any process that need heat, for example, drying, okay, and boiling, and so on. Okay, so when we have so many raw material, so many technology, so many different type of the product, when we mix up together, it becomes a very complex value chain. Then we call this biomass network. Okay, so once we have this biomass network, okay, we can put all the pricing, the operational cost, okay, the opportunities, okay, and another financial estimations. Then we would use the computing calculations to tell us which one is the most important and most worth, or we call financial advantage for us to invest. Okay, in this case, then we will propose to the investor, okay, this is the way that for you to invest in the green technology. Okay, this is the pathway that you should consider, so on and so forth. Right, we go to the next page. Okay, of course, this page I just want to show to students. If you feel like you are interested to do the proper supply chain for the palm biomass, okay, for example, this one, okay, we need to use computer to help us to analyze which one is better and which one is the second better, and so on. This is very important because we call it optimizations. Okay, which pathway is the most optimized, okay, which raw material to be selected, which technology to be selected, so on and so forth. So in this case, we have to convert all these process become equations, and we use the computer to help us to do the optimization calculations. This will be one of the very good topic for those students who love engineering, who love science. At the same time, you love calculation as well as the computer works. So combine engineering, science, and computer, then you can achieve this so-called biomass supply chain superstructure. Okay, so I make the first summary for my presentations. Biomass supply chain synthesis. Okay, our application is we can do a very good, proper supply network. And then from there, we will have the very strategic modeling, what to do. Okay, from here, we can pass our strategy to those who do the design and optimizations. From this strategy also, we can do biomass planning. Okay, we can do the processing planning and how to utilize the biomass all over the corner in Malaysia. Of course, last but not least, biomass process integrations and biorefinery is very important, that we will combine more than one technology in one we call processing hubs. Okay, I go to the second topic. Of before that, if those students, if you are interested in my work, like I presented, so you're welcome to download this journal paper that we will tell you more in details, yeah, in that paper. So second part is I'm going to talk about biomass and technology characteristic. As I showed you just now, we have the resources, raw material, we have technology, we have the demand. Yeah, so same diagram, I use another way. Now, question is, why, okay, why empty fruit branch can send to pyrolysis, okay, but cannot send to esterifications? You see, I didn't match empty fruit branch to here. Why? Why I didn't link this here? Okay, the answer is because they have certain characteristic between the raw material as well as technology. If they are not matching, then we cannot mix them together. Okay, means I cannot send this empty fruit branch to the, for example, esterification because they are not fulfilling certain characteristics. So in this case, before we link up the raw material and technology to study the characteristic for the raw material as well as technology is so important. Look at this one. Yeah. Okay, for example, so this is very old supply chain developments, resources, technology, demand, without studying the characteristic of the resources. Therefore, we will waste the value of the biomass. Okay, for example, you will overuse it because this biomass is not suitable and the yield is very low. But you want to get the demand, so you will use, okay, 400% of the raw material to achieve 100% of the productions. So this is called wasted of the biomass, even though biomass is free of charge, most likely in that case, but still, we don't want to waste the value behind the biomass. So in this case, our research group proposed add one more step, which is called resources, classification or characteristic study, technology, and then demand. Yeah, I hope this point is very clear. So in this case, we will study, okay, the classifications on 4 points. Okay, for example, heating value, nitrogen value, sugar value, and cellulose value. Because the difference of these 4 values, okay, will tell us, okay, this biomass will go suitable for which technology. Okay, for example, high heating value, most likely we will send them to the combustions. Okay, high nitrogen value, this is very important. We will make it become a good fertilizer. Okay, if this biomass is high sugar value, then we will send it to the fermentations. If this biomass is high cellulose value, then we will use it for gasification and the pyrolysis. Of course, you know, one type of the biomass, they have these 4 types of the index, or we call value. So they will create a difference. If you look at my spider nets, okay, you look at the biomass A in blue colors, and then the biomass B in the orange color. So you will see that each of the biomass actually have different patterns. Yeah, and these patterns will match with the pattern required by the technology. Okay, so this is the animation that I just repeated. Now I want to show you this one. If you look at my summary 2, okay, you look at this, it looks like the zigzag puzzle. Okay, if you remember when we are in the kindergarten or even smaller, like 2 years old, kids always play a game. Okay, there is a one model with the whole of the round shape. Okay, and the kid will put an object with the round shape with that size will put inside to the, okay, to that model. Same thing, although sometimes, okay, the model can be the star shapes. Then the kid will train themselves to find an object with the star shape, then we put inside to the model. So same thing also, we will identify in one hand the characteristic required by technology. And then we, in another hand, then we study, okay, the characteristic of this biomass. Then we will try to match them up, okay? And then this step, actually, we can enhance, okay, the supply chain development for the biomass. All right. Now, again, this is a recommendation reading for you. If student, you like this idea, then you can find this paper, okay, written by Lim and Lam, which is myself. Now I go to the third part, which is the last part for today. We call sustainability solution for biomass supply chain. Okay, combined with two parts that I presented just now. Actually, we have supply chains, and then we enhance the supply chains. Okay, all those points, we are talking about just money. Okay, do you want to invest? How much of the value of the biomass that you can harvest? But can we do more? Because biomass supply chain itself supposed to have their responsibility to make sure that environmental, clean, and green. Therefore, we can put a lot of element into this supply chain to enhance the meaning of these supply chains. For example, we can talk about the economics. Okay, so we are talking about circular economy. Mean when you do something good, actually you're not doing good for environment. Actually, you do things good for your pocket also. This will be called circular economy. Yeah, we are talking about a lot of causes. Okay, and then we also talking about environmental index. Okay, by doing, utilize this biomass, how much of the positive impact to the environment? Okay, we just not doing it, but we have to evaluate, okay, how much green I do for the environment today. So I always make a joke to the bosses. Okay, boss, I wish you become very rich, because you become richer means more biomass being converted to the useful thing. Okay, the richer you are, the greener the environment is. So I always wish all those biomass bosses very, very rich. Okay, I hope that they become multi-millionaire, because in that case, that the more biomass will be converted to the very useful thing. Okay, last but not least, social index. Okay, I believe from the first speaker, Dr. San's demonstration, actually, we are actually, our plantation actually in very outskirts, rural area and so on. If we create the utilization of the biomass, actually we create the jobs, okay, job scope and so on in that village also. From there, we can teach them how to utilize the biomass. So actually we can bring the social index along the biomass supply chain also. So I repeat, so along this supply chain, we can give a lot of value back to the society. For example, economic value, environmental value, and social value along the biomass supply chain. Okay, so again, when you want to do things, okay, optimize things, then we have to use a computer. Yeah, for example, this is we represent our supply chain simplified into this diagram. So you can see that we can have our raw material. Raw material will go to different technology, okay, different technology, then we will produce one product. So from here, we will know that every technology will have different social index, economic index, and environmental index. Or I would say in the layman term, social benefits, economic benefit, and environmental benefit. Okay, beside the benefit, we also have social penalty, economic penalty, and environment penalty. So when we say benefit and penalty, it's like we're doing account, yeah, up and down, or we call offset and so on. So in this case, when we put all this information, for example, raw material, technology, product, plus social index, economic index, and environmental index into one supply chains, then we will get a very good result that ensure, okay, this supply chain will achieve sustainable developments. For example, I run this, I can show to students. Of course, you have to learn this programming skill, okay, sooner or later, or you can drop me an email, okay? Why not? I'm always happy to teach those, especially final year students, okay, how to do these optimizations. I believe you give me 3 hours, I can give you, at least you can do this project, yeah, whatever I presented to you. Just give me 3 hours. So those who interested to learn simple optimization skill, do contact me. So you see, this is one of the options, okay, with different arrangements in the supply chain, different raw material, different technology, but okay, they will achieve different index, if you can see the index here. Okay, of course, I can also move to another structure, okay, with different index. Okay, we can have many. I just show you 3, yeah, for today. You see, By choosing different raw material, different technology, actually we can give different value of the sustainability development to the society. Okay, this is what I want to highlight to the student. Okay, so my last summary point is, okay, this when we have supply chain with those decision making characteristic, we can do a lot of things. Okay, for example, we can apply this one into the logistic management. We can apply this one into the process integration and optimizations. We can do debottlenecking. Mean from the original factory, we can, after our analysis, we can propose to the boss, okay, if you want to extend your factory, you can do this, okay, because this one can bring extra social index, extra economic index, and extra environmental index, okay, not to you also, but to the whole nations. Yeah, something like that. Okay, so my conclusion is Malaysia is no longer listed as developing country very soon. So our minded cannot stop at, okay, waiting other country to lead us. We need to be show that we are ready to be the developed country, especially in the this green technology. Yeah. So Malaysia should be a role model for other developing countries. I think we have this proud, okay? We need to be ahead from other developing countries, especially in palm oil industry. We always a big brother, okay? So we have to be ready for that, okay? Benchmarking as green as other developed country. We don't want like, you know, always debate like I think presented by Dr. Sean, Dr. Lee just now. We have a lot of issue that debatable issue that, okay, commented by other country, those from developed country. And I always tell my students, say, okay, don't be angry. People commenting us mean we have room of or opportunity for improvement. Even though some comments are too harsh, but why not take it positively means we have room of improvement. Okay, don't always blame people jealous us. Think whether we do it better, can we do it better or not? So my last word is Malaysia will be greener. Okay, thank you. Back to you, Chairman.
Thank you, Professor, for the informative presentation on reducing waste and reusing the palm biomass as value-added products. These are essentials that will propel the palm industry towards a sustainable future, and indeed, Malaysia will be greener. A reminder once again to all our participants, please do post your questions in the Q&A chat box, and your questions will be addressed during the forum session afterwards. On to you now, Dr. Tan, for the next speaker.
Thank you, Diana, and thank you, Professor Dr. Lam. Next, for our fourth presentations, we have Dr. Siti Rama Haji Abdul Hafid from the Malaysian Palm Oil Board, MPOB. Dr. Siti is currently a Senior Research Officer under the Preclinical Research Facility, Nutrition Unit, Product Development and Advisory Services Division of MPOB. Dr. Siti Rama, a winner of numerous awards, holds a doctorate degree in Medical and Health Sciences from the International Medical University. She is widely skilled in molecular biology and laboratory techniques that span immunology-related specialties in cancer research. Dr. Siti is currently monitoring multiple clinical trial projects under the RMK11 funding and remains active in numerous R&D projects on anti-inflammatory properties of palm oil, cancer vaccines, and leukemia drugs. For today's session, she will be presenting a topic entitled Nutritional Attributes of Palm Oil. Dr. Siti Rama, a warm welcome to you. Just a gentle reminder that you have 20 minutes for your presentations. The floor is yours.
All right. Thank you so much. Let me share my slides. Okay.
We can see your slide, Dr. Siti.
All right. Okay. Good morning, ladies and gentlemen. Assalamualaikum to the Muslim participants. Thank you, Mr. Chairpersons, for the introductions. And then it is an honor for me today to be part of the presenter and to deliver my presentation And today I would like to talk on the nutritional attributes of palm tocotrienol. Okay, this is my talk outline. Okay, let's go to the first of my slides. Okay, what is a palm oil? Actually, palm oil traditionally used for the edible purposes such as the cooking and frying. So it is widely used as vegetable oil in the world, and currently you can find so many products of palm oil, which is close to 50% of the packaged product find in the supermarket contain a palm oil, such as chocolate, breads, buns, pizza, toothpaste, cosmetic, shampoo, deodorants, or you can name it actually. So not only in human consumption, but palm oil used in animal feed, like what Dr. Lee said in the presentation, and it is also used in as a biofuel. So here is the palm oil, example of palm oil in our life. It can be used as a product, food product, pet care, personal care, household, laundry, detergent, and also in our biodiesel. Okay, this is palm oil, these are fruits of palm oil. Palm oil actually it's squeezed from the fruits of the oil palm tree, and the oil palm tree actually develop palm fruit in a bunches, and each bunches actually you can find hundreds of fruits. So each of palm fruit, it is contain about 30 to 35 of oil, and one palm tree actually produce about 40 kg of oil every year. And it is almost 66 billions of oil, tons of oil produced annually. So according to the National Union of Conservation of Nature, which is palm oil important for global food security and also in economic development. This is here I show you the where the palm oil extracted. This is the palm oil extracted from the pericarp, which is we call it as a flesh here. This is an endosperm, which is called extracted the palm kernel. And the pomade actually the wastewater from which is processing the fruits. It can be used as an organic fertilizer after the treatment, and after the processing, it can be used as energy like a biofuel. So here, this is the fiber, and the shell actually can be used as a boiler, which is fuel in the meals. And this palm oil actually contains saturated and unsaturated of fatty acid, which is fats and oil, vitamins, and beta carotene. This contain a lot of what we call antioxidant effects. Or here, so in the crude palm oil, this is a crude palm oil. You can there is 1% of phytonutrient. There is others also, the free fatty acid, monoglyceride, diglyceride, and triglycerides. But in a 1% of phytonutrient in a crude palm oil, we can look at there are a few phytonutrients inside, which is the most highest was B vitamin E, which is about 600 to 1000 ppm. This is what I'm going to highlight in my presentation. These are vitamin E actually in the world. There are contain two types, which is the tocopherol, the most common vitamin E in the world, and tocotrienol actually the most abundant vitamin E in a palm oil. So these as an essential of vitamin E, this tocotrienol and tocopherol is not synthesized by the body. Thus, it has to be obtained from the diet. So the lack of vitamin E actually in the body, it can cause a damage, nerve damage, blood disorders, and also the infertility. Here I show you the molecular structure of the tocotrienol and tocopherol, which is a vitamin E. The difference between these two is only the double bond in the side chain, which is the tocotrienol is more superior antioxidant, which is due to the presence of unique side chains here. And then with the three double bonds actually here, it makes the tocotrienol able to penetrate into tissue with the saturated fatty layers, which is more efficiently. So this study also reported that tocotrienol, alpha tocotrienol is 40 to 60 times more potent than alpha tocopherol in preventing the lipid peroxidations. this is the source of tocotrienol. Tocotrienol we can also find in the cereals and the vegetable that you can see in these pictures. And the vegetable oil actually provide the best source of vitamin E form, and particularly you can see that the palm tocotrienol, which is the palm oil and rice bran oil, contain the higher amount of tocotrienol. Okay, this is the palm tocotrienol, which we can also say is a fraction, because the composition, they have a different compositions like the other tocotrienol in the annatto. So the alpha tocopherol, palm tocotrienol actually contain about 20% of alpha tocopherol, and alpha and beta tocotrienol about 25%, gamma and delta, which is reside about 50% of in the palm tocotrienol. So on the benefits of palm tocotrienol, actually research conducted all over the world demonstrate that the various health attributes of palm tocotrienol. So scientific research has shown that the palm tocotrienol possesses the biophysical properties and health benefits beyond its antioxidant activity. So it is actually over 900 research studies on tocotrienol have been published, which is listed in a PubMed. Tocotrienol provide health benefits for the anti-cancer, cardiovascular protection, neuroprotection, metabolic and skin health, radio protection, and also as an anti-inflammation. So let me go one by one on the benefits of tocotrienol. Tocotrienol actually is portray an anti-cancer properties which is not demonstrated by the others. Only help to prevent the cancer, but has the ability to block cancer cell growth and initiate the apoptosis. Apoptosis means a cell death. So these palm tocotrienol actually they have suppressed the cancer cell growth, and it has been widely studied in various cancer cells such as the breast cancer, prostate cancer, leukemia, and also in the pancreas. So for the cardiovascular protections, these tocotrienol have demonstrated that promising protection properties, which is published studies reported that the ability of palm tocotrienol in reverse arterial blockage decrease the amount of cholesterol. So it is also help reduce the productions of endothelial adhesion molecule, which is reduce the atherosclerotic plaque, which is inhibit the HMG co-reductase A, which is regulate the cholesterol biosynthesis. So tocotrienol as a neuroprotection. Tocotrienol actually is a natural neuroprotective vitamin, which is the most potent for this neuroprotection was the alpha tocotrienol, and it is protect the neuron death at the extremely low level, which is a nanomolar concentration, and they are able to reach the brain and provide the protections against the strokes. So for the metabolic and skin diseases, because it is higher antioxidant activity, this tocotrienol can be absorbed quickly through the deep skin layer. So it also help promote the healthy skin barrier by reducing the oxidative effect, which is prevent the UV induced cancers such as melanoma, other related photoaging effect, which is when you consume orally or as applied as a topically. So tocotrienol actually is being used in widely application formulations such as the cosmetics and dermatological applications. So in radio protections and anti-inflammation, These tocotrienol, not only because they have a powerful antioxidant, but they also have the ability to regulate so many cytokines, which is can control the body in the bodies of inflammation. So these tocotrienol, especially in the gamma form, actually they have found as an anti-inflammatory effect and radioprotective properties. So in these slides, actually, I would like you to show, this is my work that I have done in my lab, the effects of tocotrienol adjuvanted dendritic cell in mammary tumor in biopsy mouse model. It is actually the combinations of our body immune system as an immunotherapy, which is used the tocotrienol as an adjuvant to boost the immune system. So cancer immunotherapy, or we can call it as a cancer vaccine. This work by enhance the patient immune system. Is one of the type of cancer with cancer treatment, which is an advanced paradigm in cancer therapeutic. So in a cancer immunotherapy, actually we use the substances made by the body, which is the immune cells, and then we improve in the lab to restore the immune system function. So immunotherapy by using dendritic cells actually is a rapid gaining momentum to combat the diseases such as a cancer in many countries. And then these dendritic cells, they have a good point because it is have a memory cell that they can engulf the pathogen, and then they can take properties of memories of the pathogen, and then it can present to the our immune system so that the other immune system can kill the cancer cells. Though some studies use dendritic cells immunotherapy with various bioactive compounds actually to improve the prognosis in many cancer patients. And there are also a study by Kimura in 2012, which is reported that the combination therapy of dendritic cell, which is with the chemotherapy, which is gemcitabine, was beneficial in patients with advanced pancreatic carcinoma. So in our study, actually, we used a dendritic cell. We loaded with the tumor lyset, which is the tumor lyset from the cancer cell, which is this is a 41 cell. Tumor lyset means you make the cells, the virus attenuated. It is, we kill it, but we remain the properties of the tumor so that it can prime the specific anti-tumor immune response in our body. So DC activate the naive T cell, which is our immune cells in the body, and they try to generate the specific immune response of the body. So we use the TRF, which is palm tocotrienol, as an adjuvant in our breast cancer model to boost the immune system of the body. Here I show you the 3 animal studies that I will present here. The first one is the prevention model. Prevention model actually at day 0, actually we give a vaccination to the mice, and then 3 times vaccination with 3 consecutive weeks, and then we leave it until 14 days and give a rest until day 21, and we inject the tumor, as well as we give them orally gavage of 1 gram mg per kg of TRF every day, and we monitored the tumor growth after that. So okay, the results is we look at the tumor size. We have a few groups here. The control group, which is we induce the tumor, but we not doing any treatment on the control group. We have a TRF itself. We have a DC vaccine. We have a DC plus TRF, and this is our experimental model, which is DC vaccine plus the palm tocotrienol. We look at the tumor size here. It's a smaller tumor size compared to the other group. And then the control group shows a bigger tumor size. Here we look at the number of mice develop a tumor in each group. Each group actually consists of 5 mice. And then when we look at the control, it is 5 mice develop a tumor in this group, 5 of 5, and it is also in the DC plus the tumor lyset group. When we look at the TRF, there is only 4 mice developed out of 5, develop a tumor. When we look at our experimental group here, we can see that 2 out of 5 mice develop tumor and it is remains static at the, static at the week 6 until the end of the study at the week 7. So here is the interferon gamma and IL-12. This is the parameter that if you want to look at the immune system, you have to measure this one because they are responsible for the immune system in the body. Let me explain what is the interferon gamma. Actually, it's a key component for the cell-mediated immune response, and it is usually used for the adjuvant immunotherapy. And IL-12 is a cytokine which is expressed in dendritic cell and macrophages, which is in our immune system, and it is a potent stimulator for the NK cell. NK cells is natural killer cells. They can directly kill the tumor cells, and CD8 T cells actually is cells, the immune system that have a memory cells, which is responsible for the long-term protections against the same tumor. It is protect the body from the recurrence of the tumor. So here we look at the interferon gamma and IL-12. We can see that there is, in this group, in this our experimental group, the interferon gamma increase compared in the interleukin 12 and in the natural killer cells as well as in the CD8 T cells. Okay, for the second group of our study is here to look at the treatment model. At day 0, actually, we have implanted the cancer cell into the mice, and we let it develop for 14 days. So we can mouse to be establish a tumor, and then after that we inject the DC vaccination 3 times like the previous one, and then we give them the supplementation of 1 mg tocotrienol every day, and then until the end of the study we look at the tumor size here. This is the group, our experimental group with the tocotrienol. We can see that the tumor size is quite low compared to the other group, which is untreated and vehicle. Vehicle means the group that we provide the treatment with the soya oil. You can see that's a bigger tumor size here. Here the gross picture take after we sacrifice the mice, and it is fixed with 30% of formalin. It is actually its lung, it's not a spleen. This is a normal mice. We take out the lung. You can see that we can compare with the experimental model here with the TRF, this vaccine with the TRF. It's almost the same. And from the control group, we can see the huge and the bigger, and there's a lot of nodules here, and a metastatic tumor, and also in a vehicle. We can see that also in a DC group and DC plus tumor, that there is a small tumor here, nodules here. It is represented the metastatic in the cancers. So here we culture the spleen cells from the mice, from the treated mice, which is our experimental model. And then we look at, we culture with the 41, which is we have treated these cancer cells, which is they are not able to grow anymore, but they represent the properties of the cells so that we, the immune system can recognize them. So here we also look at the interferon gamma. It is also found higher in the experimental group compared to the others, and it is a similar expression we found in interleukin 12 in this splenocyte culture. But the animal study with the treatment model, same like previously, but we have done in the time-dependent manner. It is a group that we inject the mice with the cancer cells, and we let the tumor grow until day 14, until it reaches a palpable size, which is 2 millimeter cube. So at day 14, actually, we have one group which is will be start vaccination with the 3 consecutive weeks, and then 1 week after this treatment for the G1, we have a G2. And then 1 week after the G2, group 2, we have a G3, which is group 3, and the others G4 and G5. So in this study, we look at the image of a coronal plane scanning using the MRI scan. We can see that this is a positive control. Positive control, actually, the mice inject a tumor, but no treatment. We can see that from the first of the study, week 4, actually, there's, and then the end of the study, it is become bigger. The treatment one, which is a tumor palpable, we start the treatment. We can see the tumor is still small, and week 6, we can see that it is become bigger, and at the end of study of week 8, we can see that the tumor shrinkage able to inhibit the tumor size. And then with the treatment too, also we can see that bigger in the week 4, because it is, I mean, they are started the treatment late compared to the treatment 1. And at the end of the study, we can see that the tumor volume is about 36 millimeter cube. It is a screen, the tumor become smaller after that. And then this is also the treatment 3 and treatment 4. We can see the size is almost the same. And also the lead treatment, which is a treatment 5. 4 weeks after we inject, we give a treatment for the first group 1 actually. So they are having a tumor is a smaller compared to the other one at the week 6. So this is the histopathological changes in tumor. We can see the necrosis. Necrosis actually is a cell death, but unfortunately, I think it's not really clear to show you here. But we can see that there is a necrosis in this group. So, as a conclusion of this study, actually, the combination therapy of BC vaccine with TRF supplementation in established tumor of biopsy mouse model, it is selectively killed the tumor cells and also enhance the anti-tumor immune response. Early treatment with BC therapy and the TRF supplementation actually increase survival of mouse and further inhibit the tumor progression. So the data generated from this study actually essential for the successions of clinical translation by addressing the dosage of the tocotrienol we use and also the time treatment of the tumor detections. It is also the potential of palm tocotrienol as an adjuvant, which is to boost the immune system during the study in developing cancer vaccine, which is very quite promising. So this study actually has a potential in translating into the human trial. Last but not least, I would like to acknowledge Malaysian Palm Oil Board for supporting the study and also the committee for the MPOC-Swinburne University Educational Outreach Program for the invitation. That's all. With that, I end my presentation and thank you for your kind attention.
Thank you, Dr. Siti. A very informative talk on the nutritional attributes of palm oil. It is great to gain new perspective on the inherent health values of palm tocotrienols and how it will help to improve the overall immunity, wellness, and quality of life. Thank you, Dr. Siti. Again, a gentle reminder to all participants, please be sure to post your questions in the Q&A chat box. Your questions will be addressed by our speakers later in the live Q&A and forum session. Over to you, Diana, for the next speaker.
Thank you, Dr. Tan. Oh, wow. It looks like we have already come to our 5th and final presentation of the day. It will be delivered by Dr. Ruslan Abdullah from the Malaysian Palm Oil Council. Dr. Ruslan has been in the palm oil area for almost 40 years. He started as a biotechnologist at Kumpulan Guthrie Berhad and continued to pursue teaching at UKM, where he was an associate professor. Thereafter, he went to several organizations, including San Darby, and is now serving MPOC as the Director of the Science, Environment, and Sustainability Division. Without further ado, I'd like to welcome Dr. Ruslan Abdullah to deliver his talk entitled Challenges in the Oil Palm Industry's R&D. Dr. Ruslan, a gentle reminder, You have 20 minutes for your presentation. The floor is now yours.
Thank you, Diana. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all of you. Today, I would like to talk about the challenges in the oil palm industry R&D. I hope at the end of today's event, we will see more young minds like you all to embark on this interesting path in the oil palm industry and eventually make it as a long life career. To begin with, let us go back to history. Okay. This has been mentioned by the previous speakers, but I just want to highlight that the oil palm tree is not native to Malaysia. It was brought in from West Africa to Malaysia via London and Delhi in Indonesia. It was first commercially planted in 1917. Today, it comprised of about, it contributed about 31% of the total global oils and fat production, which is about 239 million metric ton. And oil palm or palm oil is a heavily traded oil. It is the only oil that has been certified sustainable, and it has been identified by the United Nations as one of the possible oil that can address food security in years to come. Okay, why is it oil palm is so important to Malaysia? So we are the second largest producer of palm oil with a current hectarage of about 5.8 million hectares and with a production of about 19 to 20 million tons of CPO every year. And we export about 60 million tons of those that we produce every year. And it involves more than 500,000 smallholders, and it provides more than 2 million job opportunities. And it contributes to about 60 to 75 billion ringgit in terms of revenue, which contribute to about 5 to 6% of our national GDP. Okay, let us look at the, let us go back to the history. Okay, since the first commercial oil palm trees was planted in 1917, now it's 2021. So we have got more than 100 years of continuous improvement. So as I said just now, the oil palm tree was first introduced by the British into Malaya, and then it went for commercial planting in 1917. And in 1960, the government embarked on a large-scale expansion of oil palm planting. And by 1975, Malaysia began exporting processed palm oil through the extraction of CPO and CKO and to produce it into a specialty oil. Then in 2006, Malaysia was overtook by Indonesia as the world's largest producer of palm oil. Then in 2008, Malaysia became the first country to produce and export sustainable palm oil. In 2013, Malaysia established the Malaysian Sustainable Palm Oil, where the government make it mandatory for all the oil palm to be produced by Malaysia to be certified sustainable. And now in 2021, we have got about 87.75% of our plantation certified under the MSPO, and we have got 96 of our mills being certified MSPO. So where do we go from here? Okay, before we go into that, the oil palm industry can be easily divided into the upstream, the midstream, and the downstream. The upstream will involve the plantation, anything that is involved in planting the plant until the crop being harvested. The midstream involve the harvesting of the crops that goes to the mills for processing to produce crude palm oil or crude kernel oil. Then the downstream will involve the processes involved in treating the CPO and the CKO into specialized products to be used in their application. Okay, let us look at the upstream. The upstream involve the establishment of the good agriculture practices when we first started involved in the industry. Then in the year 2000 and so, we were able to sequence the total genome of the oil palm trees, where it enabled molecular breeding to be taken into our breeding program. And it also involved a lot of other subsidiary research, for example, the pests and diseases, the production of improved planting materials, and then addressing some of the main problems associated with the industry, such as the vessel stem rot is caused by Ganoderma, and the extensive losses due to rats attack, and the extensive losses due to backworm attacks on the oil palm frond. As a result of continuous R&D, what we have got today is more or less a very sustainable oil crop, which is able to be one of the most highly productive crop when it comes to vegetable oil crops. Oil palm is able to produce 4.4 metric ton of oil per hectare per year, and compared to about 0.75 metric ton per hectare per year from rapeseed, which is the closest rival. And this particular slide shows the impact of the backworm. This is the backworm, which actually feeds on the frond, and it causes the frond to die. And because of the frond dead, there is no photosynthesis, and it will require about 2 years for the palm to recover to back to normal. So if they are not treated correctly, so you will not be able to harvest any yield. And on the midstream, as I mentioned just now, oil palm produces two different types of oil, the crude palm oil and the crude palm kernel oil. The crude palm oil can be fractionated into various kinds of products. Similarly, in the case of palm kernel oil, it can also be fractionated into various products. And what is important for us to take note is that each of these oil have different composition, which make it very unique, which make it more versatile in terms of application as compared to other oils like such olive, soybean, sunflower, and corn. Okay, this is a typical oil mill in the oil palm industry. What we have here is an oil palm mill. We have got the pond for them to treat the palm oil mill effluent. We have got the mills where the fruits have been crushed and the oil extracted from the mesocarp, and also from the kernel. And then this particular picture shows what is being done at this moment in time. The palm oil mill effluent are being treated in ponds, in aeration ponds. And now, as of 2014, the government put in place that all palm oil mill effluent pond must capture the methane that is being produced, as what you can see here, which is actually a methane capture facility. And this is actually a picture of refineries, or what happened in the refinery. Okay, based on the versatility and the unique composition of the palm oil and palm kernel oil, there are many applications to these two products. As you can see here, it covers from toothpaste to shampoos to concrete additive, pest control formulation, pharmaceutical cream and ointments, ES, oil exploration, and everything. So whatever that you want to produce, you can use the building blocks in the palm kernel oil and palm oil to build up. These are some of the products that you can normally see in the supermarket. People like to use that more than 50% of the products that you can see on the shelf to be containing palm oil, but I would say that more than 75% or 80% of the products that you found in a supermarket will contain palm oil. Okay, palm oil can also produce, or oil palm trees can also produce biomass, that what has been mentioned by Prof. Lam just now, for us to use in various applications. So these are some of the applications that we can use the palm oil biomass. Okay, now we come to the main topic of this particular talk. Okay, what are the challenges in terms of the oil palm industry? We have survived 100 years of the oil palm industry. From the onset of the industry, we have developed various technology. We have been able to produce improved planting material. We have been able to produce products that can be derived from palm oil or palm kernel oil. But where do we go from here? Okay, where do we go from here? Before we can talk about moving from where we are now, I think we have a very big challenge in front of us. First, let us look at some of the challenges. One is the misconception about the oil palm industry. When people talk about oil palm industry, they always relate to working in the estates. Okay, working in the estates meaning that you don't be wearing nice outfit. You will be working in isolation, away from the community, away from the glamour. But little that we realize that the oil palm industry covers all facets of science and arts. You just name any career, you can find it in the oil palm industry. The oil palm industry is often associated with the 3D. What are 3D? Dirty, difficult, and dangerous. So when we talk about working in the oil palm industry, they will always associate to working in the estates, which are normally dirty, which is dangerous, and it is difficult. So you sweat a lot, you deal with all kind of dirty stuff and things like that. So these are the misconceptions that we have to address. And unfortunately, agriculture is not a training choice nowadays. When people go to the universities, when they ask them what do you want to be at the end of your study, nobody pick agriculture, or very few pick agriculture. They will go towards anything that is very glamorous, like doctors, engineers, all those kind of things. But very seldom people will put agriculture as their first choice. And when you talk about the oil palm industry, you are talking about long term, and it needs patience and passion. Okay, for you to be able to appreciate the outcome of your R&D, you have to have the patience and passion in the field. So if you don't have these two, I don't think you'll be able to enjoy a very interesting career in your whole life. And I would say that the R&D in the oil palm industry is very stereotyped. Why do I say that? It's because if you send people to do their PhD, for example, look at, say, palm oil meal effluent treatment, they come back, their work will always confine to palm oil meal effluent treatment. So, or if they are doing genetics, they will always confine their field into genetics. So they are not able to mix and match all the available technologies that is available on the shelf to have a broader views on R&D. And very often than not, most of the researchers are not able to think outside the box. I want to quote you, for example, what we are looking at in terms of one of the challenges in the production of oil palm. That is mechanization in harvesting. So there's been a lot of work being put into harvesting. There has been a lot of research being put to harvesting, but most of this approach are looking at a very confined issue of how to bring the crops from the top of the palm to the ground. Okay, so they will develop tools like chantas. They will develop light pole harvesting tools, but very seldom people think about, okay, now the issue is how can we bring the fruits from the palm to the mill. I would consider harvesting as taking the fruit from the palm and bring it to the mill. And when you do the harvesting according to the old way, is that you cut down the bunch, you bring it down, it falls on the ground, the enzyme lipase is being activated due to damage done on the crops. And then because lipase started to act, the oil become rancid. And by the time they send the fruits to the mill, the percentage of rancidity has increased. The percentage of free fatty acid in the oil has also increased. So very seldom, or I've never heard anyone looking at harvesting, trying to address how can we avoid the bunch to drop on the ground, and you stop the lipase from activating, and you bring the fruits directly to the mill without the bunch being being in contact with the soil, where you have to clean the fruits later on. So I would say that if you are very confined to what you are doing, you are not able to look at it holistically. So your process of developing R&D output will be very confined, and it will be in a piecemeal manner. So very seldom that you can see people looking at it holistically. And I would say that the rewards and recognition in the R&D of oil palm is I would say very low. Why I say that is because normally oil palm is associated with agriculture. It is associated to unattractiveness. It is also lowly recognized, because once if you mix around with all the corporate people, when you say that, okay, I'm working for an oil palm company, very few people would like to continue talking to you. But if you were to say that, oh, I'm from the oil and gas industry, or I'm from the finance industry, for example, so a lot of people will not continue talking to you, simply because the agriculture is being lowly recognized. It is less marketable. It stands very lowly among the social standing, and also poor recognition. There are some brilliant scientists in Malaysia, but they are not recognized. But they used to be recognized when they did their further studies overseas. But when they come back to Malaysia, they are not recognized. And this more or less, do not encourage a lot more scientists to work in the industry. Because of all these negative vibes, we are not able to attract the brain. Okay, if you conduct a survey in any of the universities, even UPM, which is supposed to be associated to agriculture universities, very few students will pick to choose to work on R&D. Okay, this is a real fact of life. A lot of them will prefer to work in areas which are more glamorous, which are more, the in thing nowadays. And because of this, there is a brain drain in terms of the people that you want to work in the oil palm industry. And I would say that this is because mainly due to the lack of awareness, because people are not aware that the oil palm industry covers every facet of science. You can talk about any career, it will involve the oil palm industry. So I think one of the things that we have to do now is we have to create awareness that the oil palm industry covers everything. And another big issue that we have is funding. Any R&D requires funding. And because oil palm is a long-term R&D effort, it requires a lot more funding compared to the short-term R&D. And this is something that I think we have, or the country have to recognize this, and they have to put some corrective measures. Okay, as I said just now, the oil palm industry brings about 70 billion ringgit per year in terms of revenue. So the government have to consider how much of those should be put back into improving the industry. But for the time being, a lot of the fundings are coming from the government, but it is still not enough. We are really looking forward to a lot more investment from the oil palm industry itself to put money for R&D for the future. And only by doing that, we are able to move away from commodity dependent, which we are at this moment in time, to downstream dependent, where we can produce novel products that can actually can determine the actual cost of the products developed from the oil palm industry. Because if you were to sell 1 ton of CPO compared to 1 ton of Tocotrienol, for example, 1 ton of Tocotrienol will bring you a lot more money compared to CPO. So I would say that there should be a lot more funding to be put into the oil palm industry. Okay, what I've done here is actually listing down what are the career in oil palm industry. You just name it. You have got agronomists, the conventional one, agronomists, geneticists, entomologists, biologists, biochemists, molecular biologists, plant breeder, nutritionist, chef, environmentalists, doctors, planters, chemists, geologists, conservationists, engineer, robotics, software developer, computer programmer, waste treatment, everything. So there's a lot of potential careers that we can actually embark on. So I think with all this, a lot more students like those people from Swinburne, for example, and those people that are listening to this particular talk will consider working into the oil palm industry. So with that, thank you. I hope I've done justice to invite and to persuade as many as possible young minds to go into the oil palm industry. Thank you, Diana.
Thank you, Dr. Ruslan, for the eye-opening presentation on the research struggles faced by the oil palm industry and also the misconceptions. It is important to identify and address these challenges. After all, R&D can help to identify possible future growth areas of the palm oil industry. With that, we have come to the end of our presentation session. The presentations will be available on MPOC's website, www.mpoc.org.my, for you to download later. A gentle reminder once again to all participants, please do post your questions in the Q&A chat box, and they will be addressed during the upcoming forum. On to you now, Dr. Tan.
Thank you, Diana and Dr. Ruslan. Ladies and gentlemen, now that we have concluded the presentation session, now we shall proceed to our forum session. We have a very interesting topic today on career opportunities in the palm oil industry. This highly awaited session includes our 4 guest speakers earlier on, comprises of Dr. Sen Nathan, Dr. Lee Chin Mei, Professor Dr. Lam Hon Loon, and Dr. Siti Rama as the panelists. And the sessions will be moderated by Dr. Ruslan from MPOC. To all esteemed participants with us here today, this is an opportune moment for you to ask any questions relating to palm oil industry. So please feel free to make use of this opportunity to pose your questions to any of the speakers throughout this forum session via the Q&A chat box. Right away, I now pass the floor to the moderator, Dr. Ruslan Abdullah. The floor is yours.
Thank you, Dr. Tan. First of all, I would like to welcome again our panelists, Dr. Sen, all the way from Sabah. Dr. Lee, I met you many years ago at UMP when I was, invigilating one of your PhD students. Dr. Siti Rahma, and also Prof. Lam. Is Prof. Lam around here? Yeah, Prof. Lam. Okay. What I will do is that I will post the question that was posted by all the participants through the Q&A, and I will try to be as fair as possible to all the panelists. So I will go one by one, so that every panelist have got a chance to talk. Anyway, as I said just now, we are discussing about one of the important industry for the nation, and there's a lot of questions that related to career and development. Okay, this first question goes to Dr. Sen. Okay, Dr. Sen, do we have a similar rescue team in West Malaysia? It will be important to increase the awareness of wildlife protection from the kids are there any potential for us to include those knowledge in our school syllabus as part of formal education? Regarding the human and wildlife conflict, what is the strategy to reduce the further expansion of human activities toward natural forests? Dr. Sen.
Okay, thank you very much, Dr. Roslan. I think I answered one or two of the questions on the chat, but it's all right. I'll answer it live. For question number one, is there a similar theme in West Malaysia? I'm not too sure. Bear in mind, because how Malaysia has been formed, you have Peninsular Malaysia, Sabah and Sarawak. Wildlife management in Sabah is under the Sabah Wildlife Department, and our purview is only the state of Sabah. So we have the Wildlife Rescue Unit, which is funded by MPOC, and it's a dedicated team that does wildlife rescues. I'm not sure in West Malaysia whether Perhelitan has a dedicated team to rescue wildlife, but I am very sure that they also conduct elephant translocations and even tiger rescues and all that. So I think they are still doing the work, but I don't know whether they have a dedicated team as we have with Wildlife Rescue Unit. Now, question number two, Dr. Roslan, I think was regarding
school syllabus.
Okay, we have in Sabah what is called the Sabah Environmental Education Network, where it is a network that involves the Sabah Forestry Department, the Sabah Wildlife Department, the Department of Environmental of Sabah. These are all three state departments, and of course the State Education Department. So it's short, the abbreviation is SEEN, SEEN. So they do actually run quite a number of modules with primary and secondary schools on wildlife awareness programs, even having workshops, and even sometimes having a sort of a weekend camp out in Sandakan. Unfortunately, for the past 2 years, because of COVID, the programs has been it's not on for the past 2 years. But yes, to answer the question, we have quite an active group involving these organizations.
All right.
And I think the third question was regarding forest protection of wildlife habitat or something like that, Dr. Roslan.
Yeah.
Right. I think what we have in Sabah, Sabah is one of the biggest, the state that has the highest acreage in palm oil plantation. I think it's around 14%, Dr. Roslan, it's about 14%. Yeah. Having said that though, the Sabah government has actually taken a very brave and bold initiative to actually further protect forests by in fact increasing the amount of totally protected forests. I think our target is about 30% totally protected. Besides that, more than 50% of Sabah is under total forest cover. One, I think I can say an example that can actually see that what Sabah is doing is the orangutan population. 15 years ago, Dr. Roslan and ladies and gentlemen, more than 60% of the orangutan population or habitat was outside protected areas. So we have actually taken steps. In fact, right now, 75% of orangutan population is in protected areas. So it's really a reversal of how it was before. And this can be seen in the number of orphan orangutans that come to Sepilok Orangutan Rehabilitation Center. From 2000, the numbers of orphan orangutans, which normally happens when you have forest areas which are cleared for whatever reason, has gone down. In fact, it has trickled down from around maybe 10 to 15 a year back in 2000 to less than 2, or sometimes even I think this year was only 1 orphan orangutan. So that is a very good yardstick to look at how well Sabah has been progressing in orangutan conservation in Sabah. Thank you. I hope that answers the question, Roslan.
Okay, thank you, Dr. Sen. All right, Dr. Lee. Okay, methane is a potent greenhouse gas, 20 times more powerful than carbon dioxide. in your opinion, how urgent is it for the Malaysian government to find ways to commercialize the capture of methane and other biogas from palm oil mill effluent towards an environmentally friendly future of the oil palm industry? Are there any low-hanging fruits that the government can tackle first?
Thank you for the question. Yeah, I think methane is being produced a lot by the treating the pomade, and of course it's really urgent because now you see the global warming is affecting our life, right? The weather is so hot. But I still think that to use the covered lagoon is one of the easiest way to capture the biogas and to be used in the palm oil mill. Right. Any low-hanging fruit? Yeah, I think the covered lagoon would be the best way.
All right. Okay. Thank you, Dr. Lee.
Thank
Okay.
you.
Dr. Prof. Lam, yeah? Yeah, Prof. Lam. Okay. Some supply chain literature and industry players have identified that one of the main barriers to a successful biorefinery industry is the lack of sustainable supply chain for feedstock, particularly feedstock logistics. What is your view on this particular issue?
First of all, I very much agree on this point. Now in Malaysia, we are lack of the system to collect the biomass and send to somebody the demand side. So we have a lot of biomass, we have a lot of demand, but we do not have the well connection between supply and demand. So I tell you now, Malaysia's biomass become one situation is the demand more than the supply. I tell you, our demand for biomass is, you can't imagine. Yeah, the price actually is increasing. You know, those businessmen that trading the biomass, listen carefully. We already have a trader for biomass in Malaysia that they will trade our biomass directly to overseas. Okay, for example, to Japan, Korea, as well as China, and also our neighboring Thailand. No, because in those 4 countries, actually, they already have the green energy policies. For example, in Japan, now they only will reward the power generation plants to the green energy. So to fulfill this, to have the license in Japan, so they must have the co-firing, means at least 50% from the source is supposed to be biomass, and Japan doesn't have biomass. So this is why they will come to Malaysia or Indonesia to take all of our biomass back to their country. So, you know, who is the one work for this, then they will get the biomass source. So those big businessmen, they will take all of the biomass they can send to Japan, Korea, as well as China and Thailand. So in this case, Malaysian, you know, we are slightly not that active or proactive to fight for the biomass source. This is why the biomass left in Malaysia itself is, as just now the question said, is not enough. This is the problem. But my point of view is, my answer is not enough. Actually, is we are not able to collect successfully and systematically and send over to whoever need this biomass. So the key answer is we need to improve our supply chains, our facility, our system, okay, in order to do this. Okay, how to do this? Very simple. We need a motivation and a driver, which is when we increase the biomass price, I tell you, all the facility, all the transportation company automatically will set up. So I believe I myself will be very positive on this one. When the biomass price reach to a very good price, all these company automatically they will set up by themselves. Of course, right. We need to make a good policy to control this. Yeah, thank you.
Okay, thank you, Prof. Lam. Okay, Dr. Siti, I apologize for not introducing yourself just now. Okay, Dr. Siti, the question is, olive oil has always been recommended in healthy diet plan. Can we use palm oil to replace olive oil? Will the diet still be considered healthy?
Actually, it depends on what are you going to use for. If you going to use for the deep frying, it is recommended that you use a palm oil because they have a stable, actually it's stable in high temperature. If you just want to lace in your like vegetables or like the masaledu, then it is better to have the sunflower or the olive oil is a better one. But if you have like the blended oil, it is also used for I mean in the foods like vegetables. If you don't want to I mean like a stir fry, it is, I mean, it is acceptable to use like that. But if you want to use like that for the palm oil, it is recommended to use the red palm oil, which is the one that are produced in palm oil. Actually, it is better because it's high contain high beta carotene.
All right, thank you.
Yeah. That's why I recommended from my experience. We in Malaysia, not only in Malaysia, in the worldwide, it is better and that it's a less. That's all.
Okay, thank you, Dr. Siti. Even though we lost you at the end bit of your explanation. Okay, this question was addressed to me. Did oil palm plays a major role in the medical, especially to pharmacy? Okay, I think basically what I can say about this particular question is that to date, the oil palm industry have been able to identify tocotrienol, like what Dr. Siti was mentioning just now, beta carotene, and most recently the oil palm phenolic. Okay, these are some of the compounds that has been identified good to be consumed for our health. But my suggestion is that if we have a lot more brains working on the oil palm industry, I think a lot more compounds which are beneficial to health will be discovered. Okay, but unfortunately for the time being, we have only all those, as a health supplement. Okay,
yeah, I agree. Yes, I agree on that one. I think we need more brands actually to work on this one. Yeah.
Yeah. Okay.
Work more on this one.
Okay, Dr. Sen. Okay, let me check the question. Okay, I don't want to ask question that has been answered by you online. Okay. What is the most challenging situation in managing a human-wildlife conflict in Sabah that your team have encountered so far, and how have your team managed to overcome the difficulties? You are muted, Dr. Sen, you are muted.
Sorry, Doc. Okay, when you talk about human wildlife conflict, there are two things in that whole terminology: humans and wildlife. So I'll tell you an experience that I've had working with a smallholder. This was a smallholder in Lahadato, very close to Felda Sahabat, and he had a chronic problem with elephants. Okay, smallholders, I think in Sabah is around. He had a very small estate, probably around 50 hectares, and he had every day for 2 straight weeks, they had elephants raiding his crop, to a point where they were destroying 1 hectare per night. 1 hectare per night of newly planted plantation palm oil. And here you see the conflict where you see, on one hand you want to conserve wildlife, but on the other hand you see a Malaysian who is trying his best to earn a living. The problem with a lot of Western NGOs when they talk about anti-palm oil lobby, they don't go down to the ground and see that palm oil helps so much of this Malaysians who really want to make a living. So he had lost more than 25% of his plantation, and we told him, okay, and the reason why we had difficulties in corralling or translocating his elephant, this group of elephants must have gone to university. Whenever we turn up, the elephants go missing. Elephants are very smart, they can smell us. So we took 1 month. It cost us so much of money, so much of funding to actually get to translocate 5 elephants. But at the end we did. But then you see what's happening on the ground. And I pity this group of smallholders who who don't take the laws into their own hands. It's against the law to injure or shoot elephants, but they are willing to take a beating in terms of losing their investments, losing their livelihood in a way, just because wildlife is important for Malaysia. I hope that answers your question, Dr. Roslan. In a way, it's a catch-22, and this is what a lot of these Westerners don't see.
Yeah.
Thank you.
All right, thank you. Okay, Dr. Lee. Okay, in your opinion, what would it be lucrative for millers to build a facility solely for treating palm oil mill effluent?
I think nowadays there are lots of research being carried out to improve the design of the bioreactor to bring down the investment costs.
Yep.
And yeah, and I think the small medium holders, they can actually use something simple instead of some very complex system in the very beginning. They can just install a membrane to the open pond system to capture the biogas, and then they can see from there how good is the replacement of the methane as the fuel in their mill. So I've visited some of the mill. Yeah, they just have very simple setup. Yeah. Okay,
Dr. Lee, you see, in my experience, you see, there is a mismatch between technology that is being pushed forward by the technology developer and the practitioner. And one of the most advanced, or one of the biggest company in Malaysia themselves are not really convinced that that is the way forward, And I've been to various facilities where they are not just capturing methane to come up with an end product, but they are just doing it because the government says that it's a rule that you have to follow. So how do you, as an academician, how do you actually handle in trying to persuade the players to go right to the very end, rather than just stopping at the halfway after investing so much? You got your methane, you flame it and you burn it just like that. Whereas methane can be cracked into hydrogen, and then you can produce carbon dioxide, and there's a lot of downstream product that you can actually develop from there. How do you foresee that you can actually address this particular issue?
And I think nowadays in the university, we are encouraged to collaborate with the industry. So I think this is how we can actually give them, like to help them, not to say to give them, actually to grow together. Because we as the academician, always people think that we do things that without understanding what the industry needs. So I think in this way, then we can be more down to earth, and the industry can tell what's the problem. So government has a lot of funding for that. So that's why that's where we can see collaborate together.
I think this is also another challenge in the R&D, because most of the R&D that is being done in the universities are disjointed with the applied R&D that is being done in the private sectors. And I think is something that the academia and also those players in the industry have to really work together. What do you think? What do you say? What is your comment, Prof. Lam, on this aspect? I'm sure we've got something here.
Yes, I tell you, we even go to across the discipline research between engineering as well as social science and School of Business to study all this point, because we know that this point cannot be just from technology. It's supposed to be all-rounded corners to study this one. Surprisingly, we found that our result is I don't know, this truth is very funny to me. First of all, why this one we cannot go to the ideal way that we wish to? First of all, the first problem is supply chain. Means all the investors don't feel that we can achieve the large scale, the technology developments, to the end, very end, to the end user and so on, because we do not have the market or facility to support this one. For example, we talk about the gas, methane or even hydrogens, but do we have a proper market to absorb all this methane or even hydrogens? So I was, for example, I think 4 years ago, I was in Japan as a visiting professor there. You know, I was in their Institute of Technology of Tokyo. They already have the roadmap for hydrogen network in Japan. Means by I think year 2030, they will started, instead of the pumps, petrol station, they will have the hydrogen station for those hydrogen car. So in this case, if they have this proper development and so on, so those technology to produce hydrogen will be very much welcome to be commercialized, because the another end is ready. But I think in Malaysia, we cannot see all those supply chain things. So raw material got problem, technology got problem. The most important is we do not have the final goals to go, which is very rare. I think in Malaysia, our final goal is still very much on R&D and so on. This stop all those real developments.
Okay, I want to expand a little bit on that. Because of these common issues in R&D that maybe involve Dr. Siti Rahma as well, I would say that the R&D that is being done in the universities and research institute seldom reach the marketplace. Okay, as you pointed just now, logistics is one problem. Or I would say that there are too many champions that spoil the whole, the whole concept. For example, you talk about biomass. The moment the government set up the national biomass, policy, okay, there were mushrooming of agencies who claim to be the champions in biomass.
Yes,
so much
yes,
so
true.
that people got pissed off and they lost faith in the actual work that can be done and can contribute to industry. What is your take on that? Maybe Dr. Siti Rahma also can chip in, or even Dr. Sam can chip in those questions. What do you think? What shall we do? I was in the academia for many years, and I found that everybody wants to be a champion. So much so that people, when the government, I remember in 2004, if I'm not mistaken, the government have got the biotech policy. They put aside 80 billion ringgit, no, 8 billion ringgit for biotech research. And from there, everybody that goes around passing their business card, they claim themselves to be biotechnologists.
Yes,
they
I
don't
remember.
even have a clue on what biotechnology is all about. And when the money runs dry, the people's faith in biotechnology also went dry. Okay, now we are talking about Pomade capture, we are methane capture, we are talking about biomass. It's the same thing that's happening. Are we going to go through the same cycle again? So probably those in the academia should say something, because you are the one that is actually depending on so much on the grant. It's not the businessman. What is your take on this? Or just angguk-angguk kepala ni?
Let me give some example. Maybe this is not directly answer you, but I think from this example we can find the answer. For example, just now Dr. Siti talked about the red palm oil. Yeah, we all know red palm oil is so good. A lot of research has been done to prove that red palm oil is one of the best oil in the world. I would say real. If you look at the statistic, the data, wow, this is the best oil. Why this is not the most expensive oil in the world? Why this is not the most welcome oil in the world? You see, the result tells us this is the best oil, but the outcome at the end is not the best price, best accepted. So you see, in between the connection is a problem. So I see that because now we have few countries in Malaysia develop the red palm oil in productions. Because this is their business. They will try their best to tell the world this is the best oil. Now our oil reach Japan, reach Europe, our red palm oil in good branding and so on. So this is the thing that I think our policy or government should think not how to do it. I think our project a lot at the end become white elephant because they do not really go out, because this is not their real benefit. If this is a real business project, like I say, red palm oil now reach Japan, reach a lot of countries, because this is their real business and they take it as become their responsibility. I think always in Malaysia, the main problem is research policy. At the end, the main thing is we do not have a real policy to push until the end.
Okay. Any views from you, Dr. Rama?
Yeah, actually, I agree with Dr. Lam. And then actually, regarding that one, actually, when we look at the promotional, the marketing, how we market actually into the country, like we should have a different approach for me. Let's say if you are promoting into Japan or Korea, we should have a different approach compared to the Europe one. This is the main problem actually for us. Sometimes the research actually, what we have done is not reach them. That's the main problem, because we are also the researcher, like the the lecturers like Dr. Lee and Dr. Lam. We are in a same boat actually, but the thing is, we also need the the government to enhance the marketing into, to the different country, that we can, to reach the way they promote the oils, like the soya oil. But as we all know that we is really a target for the European country actually. So in terms of that, I think the most of, we have to increase our promotional, how to market we have to tackle how to market the oil actually.
All right.
That's my concern.
Okay. Okay, there's a question here that was posted to MPOC. How do you overcome the anti-palm oil campaign in the industry? Okay, I think what we have to know is that this anti-palm oil campaign was initiated by competitors to the palm oil. Okay, if you look at the history in terms of the production of vegetable oil, the oil palm or the palm oils became #1 used oil in the world, dislodging oil like soybean and rapeseed. Okay, and because the industry is so huge, the amount of money that is involved is also very big. And you can see that this anti-palm oil campaign is mainly centered around in Europe. Okay, in Europe, to a certain extent in US, but very little from other part of the world. And there is reason to that. Why Europe? Because we are dislodging sunflower oil, rapeseed oil, and corn oil. And where does this oil come from? From the European countries. Okay, and that's the reason why this anti-palm oil campaign came about. So in year 1990, a lot of those claims on anti-palm oil campaign are based on health materials, on health reason. They say that oil palm is bad for your health and so on and so forth. But at that time, the Malaysian government embarked with R&D that was conducted by laboratories elsewhere in the world. And these laboratories showed that oil palm that produces palm oil is healthy. Okay, is healthy. And from then onwards, they moved their focus from science-based into perception-based. So this is where issues like, we are killing the wildlife, we are doing deforestation, those kind of things. And perceptions are very difficult for us to dispel, right? And it's very difficult for us to dispel. The only way that we can do is in addressing that is to continuously to communicate, to tell the world what is it that we are doing to say that we are saving the wildlife. That's why we initiated the WRU as one of our arm for the oil palm industry to show to the world that we are taking care of our natural resources. Okay, and we will continue to communicate, plus the fact that there will be some beneficial input from the health sector. So we will continue to do that. Right. Okay, I want to ask another question. Yeah, Dr. Sen, you want to say something?
Yeah, may I add on with regards to the issues with anti-palm oil lobby? Because we have first-hand knowledge that we are in a way frontliners in terms of this anti-palm oil lobbying. In fact, just to add what Dr. Roslan is saying, they've gone from scientific issues to pseudo-scientific issues. And, unfortunately, orangutans has become their poster child for anti-palm oil lobbying. And as a Sabahan, as a Malaysian, I can assure you that, 25 years ago, those perceptions, those accusations might be true. I'll be very honest with you. But the Malaysian palm oil industry has cleaned up its act the past 25 years. Having said that, because we in Borneo, Sabah, Sarawak is in Borneo, and there's also other parts of Borneo which is not Malaysia. Unfortunately, in other parts of Borneo, this kind of accusations sometimes do ring true. So the problem is then we are all put into one basket. That is the biggest problem. And I think one of my biggest challenges, when I go overseas, when I talk to all these foreign NGOs, they clump us all together with our neighbors. And, it takes a lot of convincing. It takes a lot of numbers. It takes a lot of statistics to show them, look, we are doing a better job. Our orangutan population is stable. I can't say the same for the rest. So this is the biggest challenge that we have. It's those half-truths. It's not happening in Malaysia, but it's happening across the border. Thank you, Dr. Roslan.
All right, thank you. Okay, this question goes to Dr. Siti Rahma. Okay, Dr. Siti, tocotrienol is one of the ingredients for UV skin protection. Since tocotrienol is obtained from crude palm oil, would that make the skin become too oily?
Oh, actually, it's a good. It's how to answer that? But I think it's good. Because it's not because too oily. It's help to to restore the moisture in your skin. Actually, that's antioxidant. Actually, it works on the your skin. It's help to retain moisture. It's not, it's because to develop more oily to the skin. It's a different perspective actually. Yeah, if you look at the barrier, it's a skin barrier. Actually, you can, what I can say that actually we are collaborating the studies on this one to look at the skin health. There one study actually from USM. They are conducting on this one, and it is a human trial. And then one more actually is going to be conducted soon, which is through the Tocotrienol matching grant. We can look at that result actually. I can't say too much about it, but we will look on the proof through the scientific research.
Okay,
yeah.
Thank you.
That's my question answers lah.
All right. Okay, Dr. Lee, is there any study on or possibility for the waste of palm oil industry to be turned into biodegradable plastic?
Biodegradable plastic? I think so, but I'm not really familiar with it. Maybe Dr. Roslan, you can help with that.
Okay. Well, I did my earlier work on genetic engineering on the production of bioplastics in palm. Well, the idea came from a report that was published by a group of scientists in the US on the possibility of diverting the metabolic pathway of acetyl-CoA from, to form bioplastics. Okay, to form bioplastic. And what we did was we did some genetic manipulation of the oil palm gene, and to include this particular enzyme that will divert the conversion of acetyl-CoA towards bioplastic rather than going into palm oil. So it was successful scientifically, but it was not viable economically because the leaf became a little bit more difficult for it to undergo photosynthesis. But conceptually, it can be done in the plant. If you are talking about industrial waste, yes, there are some work that's being reported in the journal showing that using certain microbes, you can convert the waste into bioplastic. So theoretically, it can be done. Whether it can be viable economically or not, I don't really know, because I remember about 4 years ago, there was a company from US that came over saying that they can convert palm oil into bioplastic. Whether it's viable or not, that remains to be seen. Okay, back to the questions. Let me check. I hope I will. Okay, Dr. Sen managed to answer most of the question online. Okay, maybe I want to ask your frank opinion on this. Dr. Sen, with the strict regulation imposed by the Malaysian government, are there still many illegal poachers in East Malaysia?
Unfortunately, yes. I have to be very honest. There is the trade of illegal bushmeat is big. One of our biggest challenges is enforcement of illegal. Yes.
So what do you think happens there? They are not enforcing?
Well, they're not enough. They're not enough enforcers, Dr. Roslan. Okay. Just have a look at our department. Our department has a number of personnel, 189 personnel, covering 70,000 over square kilometers of land mass of Sabah. And that 180 are not all wildlife rangers. That's going to be a mix of officers and admin staff. So we have probably about 60, Dr. Roslan, 60 wildlife rangers and officers who have been who has been administered to do enforcement work, and the areas are just too big. Hence why we have this Ops Khazanah. This has actually helped Sabah, I think, and it's helped also West Malaysia really well, where with the assistance of the police, the military, Sabah Forestry. I mean, it's a joint effort that has helped a lot, Dr. Roslan. Okay. Besides that, I think that even the palm oil plantations have also been very helpful in making sure that there is zero illegal hunting in their plantation. So that has helped a lot.
Okay, great to hear that, because you see, we have always been blamed that the planters are the one that is killing the animals. So it's great to hear that we are the one that is saving the animal.
Dr. Roslan, those days when there were a lot of cowboys in the plantation industry, yes, but not anymore.
All right. Okay, this question goes to Dr. Lee. Dr. Lee, maybe you are aware of this. Okay, the government imposed a ruling in 2016, if I'm mistaken, that all new palm oil mills must have the methane capture facilities. And all mills were given 1 year to install to have modification on their mills and then to install these facilities. To your knowledge, what is the percentage of mills that have got that facilities in the country at the moment?
So
that's 455 mills altogether.
Yeah, so I did some research. I think there's about 34% of the mill.
34?
Yeah, 34%.
So what happened to the 66%? Are they being penalized? Are they willing to pay the penalty or what? Or the price of oil palm is too good, so they can pay the penalty being imposed on them?
Yeah, are we talking about the enforcement, right?
Again, enforcement again. All right.
Yeah, but I've seen in some of the big plantation, like some Dabi, they have posted online, it's about 10% nowadays. Their meal is quite low. Only 10% of their meal have the biogas plant facilities, and they are planning to install up to 50% in 10 years time. So it's not 100%. Yeah, that's the research that I've done. Yeah, I hope it will be increased.
All right. So meaning to say that the rules are being being put in place, but people just don't bother to follow it. That's very sad. That's always the case in Malaysia. We have got a lot of master plan, roadmaps, policy, rules and regulation, but implementation wise, enforcement wise is still very sad. Okay. Okay, I've got this question for, let me check. Dr. Lam also answered a lot of questions, online. Okay, Dr. Lam, this is not really a question, but this is just a request from one of the, probably a representative of the final year student. They say that they want to do a project with you. Will that be possible?
Can.
Anything, can it? 3 weeks,
can just drop me email.
3 weeks or 3 months?
Yeah, drop me an email. I'm happy to supervise as your co-supervisor. You know, this is investment because I want you to be the good researcher.
Yeah,
that is a big reward to us. Yeah.
Yeah. Okay, Dr. Siti, with the health benefits of palm tocotrienol, would you recommend to consume palm tocotrienol as a daily nutrition supplement as compared to regular vitamin E, like for example, tocopherol?
Yeah, actually it's a... Hello, can you hear me?
Yeah, we can.
Actually, yes, it is better to have a tocotrienol than tocopherol because it is more have a potent antioxidant. It is not only for the skin, it is also for the eyes. And it is also help to, I mean, it is proof that there are a study on the, in protecting the hearts actually, and also the stroke. So it is more better than tocopherol. So my suggestion, yes.
Okay, good. Okay, I've got this question posed to me. Dr. Roslan, how do you think that we can increase the attractiveness of palm oil industry, especially among the youth in Malaysia? Well, I've been in the industry for the past 40 years. I don't see any improvement in this thing. I think the biggest challenge is actually to make people understand what is oil palm, what this industry is all about. A lot of people think that when you talk about oil palm, it's working in the estates, you know, nothing beyond that. But if you were to listen to, let's say, Dr. Siti, I'm working on tocotrienol isolated from oil palm. Boleh kah? Is that possible lah? Boleh kah? You know, that kind of question. So, I mean, these are the main issues. So, how do we actually overcome, you know, these challenges? I think it cannot be done by one person. It cannot be done by a single institution. It has to go through all the way along the value chain.
It is a
from those people on the upstream, midstream, downstream, and so on.
Yes,
including the government. Okay, so that's why in my second last slide, I put there the challenges are involving the economy, the social, and the governance. Okay, only with all these three components, then hopefully we can actually influence more people to work on oil palm. So, and we should actually change the mindset that oil palm is working in the estates. Okay, there are also people working, there are medical doctors who are working on oil palm. Okay, there are computer programmers working on oil palm. There are robotic scientists that works on oil palm. So we have to change that. But as I said, it cannot be on one organization alone. It has to be everybody. The industry and the academia and the government. It has to be. Yes, sir.
There are also veterinarians working on all.
Oh yeah, sorry, I forgot to include you. I forgot to include you.
Okay. Dr. Roslan.
Yeah.
I want to add on a point from your opinions. Actually, now Malaysia, the palm oil industry is going towards sustainability. We call MSPO. Yeah, I think. Those students, you can just simply Google MSPO, because when Malaysia, actually we're supposed to be ready last year, maybe COVID problem we delay it a bit. When Malaysia is ready to be sustainable, which we have to, you know, it's opened up a lot of the career opportunity, because even every small estate, okay, small palm oil mill and so on, we need professional to make documentations, to make from plantation to palm oil mill to the palm refinery to be very sustainable and so on. We're talking about waste reduction, zero waste, you know, and so on and so forth. So I can believe Malaysia is going toward MSPO, or we call sustainable. In that case, we need a lot of professional from different sectors to support this, which Malaysia confirm will go MSPO. Yeah, right. So I will welcome everybody. Check this MSPO. From this scope of MSPO, you will find your role inside.
Okay, this is an interesting question that I got. I just received it, which I think is very important for all of us to think about it. It actually involved some of the policymakers' decision of late. Okay, the question says, can you provide your views on the development of the oil palm industry in Malaysia in future, whether it is developing or otherwise? Okay, I would say that for the time being, you can never find an industry that can bring in 70 billion ringgit to the country every year. Okay, you just name any crop, any agricultural commodity that can bring in 72 billion ringgit to the country, right? So, but there are so many challenges that the oil palm industry is facing. We have challenges from the competitor, we have challenges from the environmentalists, okay, the true environmentalists or the pseudo environmentalists. So we have got a lot of challenges. So the question is that, shall we move forward or shall we go backward? Right. A lot of people will take the easy way out. Okay, let's look for an alternative industry. But as I said, can you find one industry that can bring in 72 billion ringgit? The answer is no. So what shall we do? Okay, if you look at the current situation, we are generating a revenue of 72 billion, and 40% of that income come from downstream. Downstream, yeah? Meaning to say that you're talking about tocotrienol, talking about specialty oil, you're talking about food, you talk about all the specialty fats and so on and so forth. And 60% are from commodity. You just imagine if you were to convert 60% of commodity into downstream product, you're not talking about 72 billion ringgit. You probably talk about 100 billion to 200 billion ringgit in terms of revenue. So this is where we need all the young minds, especially those listening today, to come forward, join forces, working in the oil palm industry, trying to develop products that can really, fetch good prices. I mean, for the timing, yes, we are enjoying 5,000 ringgit per metric ton of CPO. But if you look back, that is after 100 years. All this while, it has been, going around 2,000 to 3,000 ringgit per ton. But if you were to talk about downstreaming, probably the price is 10 times more, 100 times more. So my answer to that question is that definitely oil palm is going to stay, but we need young, bright minds to come and push it further to the next 100 years from now. Okay, we have achieved so much, so we shouldn't be, letting go the industry. We have to push it forward. Okay, maybe I can have some ideas from other people as well in this field. Want to add on to what I've said? No? Tak ada? Tak apa. Okay, I've got this question to, let me check, yeah. To Dr. Siti again. Dr. Siti.
Yes.
Based on your experience and knowledge, do you have any information on the effectiveness of tocotrienol in managing cardiovascular disease? And does the cancer stage of a patient influence the effectiveness of tocotrienol on cardiovascular disease issue?
Okay, for the cardiovascular diseases, actually we have a collaborators from the overseas. Actually, it's not from my study. For the cancer research, yes. Currently, what I have done actually was doing the look at the effect of tocotrienol on the immune system. I am more to the immune system to look at the cancers, probably more on the breast cancer cells and also the leukemia cell cancers. So from my study, actually, I have done the combinations and then look at the effects combination on the immune system with the tocotrienol, and it is also helps. It is inhibit the cells, like I presented just now. It is also inhibit the cell, the cancer cells. For the leukemia, we have done a few studies actually on the cancer cells also. And we have 5 different cancer cells on the acute myeloid leukemia. And the most potent, what we call is isomers is on the delta for us. I don't know for the others, there are also found that the other leukemia cells is on the gamma tocotrienol. But when we compare with the rich fraction, actually, there are some, I mean, different, will be have a different effect on the isomers or different rich fraction, like the tocotrienol, palm tocotrienol, we have rich fractions on it. And then when we have tested on the cell lines and the animal trial, actually, if breast cancer and prostate cancer, we can say that it is well good in rich fraction compared to the single one. But it also depends on the different types of cancer, like you have like MDA, or you will have like mouse cancer. It's a different different pathways. So we cannot see in one side. There are so many pathway which is involved in this upper cancer diseases. So we have to look at the in terms of rich fraction that can help to boost all the immune system towards all the cancers, actually.
Okay, thank you, Dr. Siti. Okay, I think we have come to the end of this Q&A session. I have to pass over the session to the MC for a Kahoot lucky draw and so on. So over to you, Diana and Dr. Tan.
Thank you, Dr. Ruslan.
Okay,
and thank you to all the panelists.
Thank you.
So I believe the participants here had learned a lot and had very good takeaways throughout this forum session. Okay, this ends our forum session. I will now hand over the session to Diana for the next segment, which is the Kahoot quiz.
Thank you, Dr. Tan. It was indeed an informative session. Now, everyone, it's time for some fun. Our Kahoot quiz. So the login URL for the quiz is www.kahoot.it. A total of 30 prizes are up for grabs. Our first prize winner will go home with a whooping 300 ringgit Zalora e-gift voucher. Second and third places will have RM 150 and 75 ringgit Zalora e-gift vouchers respectively, while the fourth and fifth places will each have an RM 50 GrabFood voucher. The remaining 25 consolation prizes will have RM 20 GrabFood vouchers each. So I hope that you guys have paid attention to our talks, as it'll definitely give you the boost. So the code for our Kahoot quiz is now displayed on the screen. Fill in this PIN number as well as your personal details. As I mentioned at the beginning of this program, you have to answer the questions displayed within the allocated time. Points will be given based on your accuracy and also your speed in answering the questions. If you are struggling to open the Kahoot quiz, please reach out in the chat box and our technical team will assist you. I see that we have players signing up already. So let's wait for some more. Can we have more? There are 30 prizes up for grabs, so please join and see if you can win some. Okay, we have 31. Can we have some more? We have 40 now. Okay, we have 60. Can we have some more? Okay, 70. Let's see if we can reach 100. Okay, we are almost there. 90. Okay, we have reached 100. Let's see how many we can do. Oh, I see, end. Okay, 107, 108. Okay, let's see if we can reach 120. Can we? We're slowly there, 115. Can we have some more, please? Okay, we Okay, we're 3 numbers away from 120. Can we have some more people signing up? Okay, we've reached 120. Let's see if we can reach more. 150 now. We have 30 prizes up for grabs. That's quite a lot. So let's try. 121. Can we have some more? Can we have some more, please? There's an RM 300 ringgit Zalora e-gift voucher up for grabs. Okay, 130. Some more. Let's see if we can get 20 more so that we can reach 150. $137. 140 now. Do we have some more people? 10 more? Just 10 more? Okay. I see that you guys are still signing in. $145. Can we? Okay, we've got 150. 151. Anyone else wants to sign up? Please do. Okay, I see that we have enough participants now. So let's start the quiz. All the best, and remember, fastest fingers and most accurate mind wins. We have 30 prizes up for grabs. So in 3, 2, 1. The first question is, what does WRU stand for? Wildlife Rehabilitation Unit, Wild Resource Unit, Wildlife Resuscitate Unit, or Wildlife Rescue Unit? Okay, we have 130 answers logged in. We have 5 more seconds. Okay, so what's the answer? The answer is Wildlife Rescue Unit. Let's see who's in the lead for now. Okay, so Turtle, you're number 1, followed by 940 and KCC, Ju and Jen. Next question. Which animals below are the totally protected species in Malaysia? Is it the giraffe, the Bornean elephant, the orangutan, or the proboscis monkey? We have 10 more seconds to answer. We have 110 answers in. 5, 4, 3, 2, 1. Okay. So the correct answer is all except for the giraffe. Okay, so we have a new person in the lead is Wei Soleha, followed by Anne, SW, Hornbill, and Mika. Next question. What is the maximum term of imprisonment if someone hunts an elephant in Malaysia? 6 months, 3 years, 5 years, or 10 years? Okay, more answers are coming in. We have 5 more seconds to answer. Okay, so the answer is 5 years. Let's see who's in the lead now. Okay, so now it's Mika, followed by SW, Tivia, America, and Yoxiong. Next question. Now it's a true or false question. 1 palm tree is able to produce 42 kilograms of oil every year. Is this true or false? Okay, we have answers logged in. And what's the answer now? Okay, so the answer is actually false. Let's see if Mika. Okay, now it's Yoxiong, Faris, Wei Soleha. Mika is now in 4th place, and SW. Next question. What does Pomade stand for? Is it palm oil mill effluent, palm oil mill efficiency, palm oil manufacture efficiency, or palm oil mill effluent? Got 10 seconds left to answer. 5, 3, 2, 1. So the answer is palm oil mill effluent. A total of 109 participants actually got this correct. Let's see who's in the standing now. Okay, Yok Seong managed to remain as number 1, followed by Faris, Wei Soleha, and Celine has actually climbed to 4th position, followed by SW. Next question. Which information below is incorrect for methane? It is a potential renewable fuel. It produces thermal energy in industrial boilers. It does not generate electricity for the mill, or it generates electricity for the mill. So which one is incorrect? You have to pick the incorrect one. Okay, so the answer is it does not generate electricity for the mill. A total of 101 participants got this correct. Let's see if Yok Seong continues. Okay, so it does, followed by Faris, Wei Soleha, Celine, and we have a new person, Sylvanier, in the 5th position. Next question. Which of the following is not an example of oil palm biomass? Crude palm oil, mesocarp fiber, pomade, or empty fruit bunch? Which one is not an example? Okay, we have 5 seconds left on the clock and 150 answers logged in. So the answer is crude palm oil. 55 participants got this one correct. Let's see if that changes our standings. Okay, Yok Seong is still in 1, followed by Faris, Tivia in 3rd, followed by M and Win Cheng. Next question. Now it's a true or false question. Biodiesel can be produced from crude palm oil using the esterification process. Is this true or false? Got 10 seconds to log in your answers. So if you paid attention earlier, this one was mentioned. So the answer is true. Let's see who is in number 1. It's Yok Seong again, followed by Faris, Tivia, M, and now we have a new one called Mr. F. Next question. Now it's a multi-selection one where you can pick multiple answers. What are the advantages of biomass element life cycle analysis? Is it able to analyze industrial waste biomass? Able to further identify potential value within the biomass? Able to utilize biomass value in supply chain model? Or able to turn biomass into crude palm oil? We've got 120 answers and it's okay, so it's all except able to turn biomass into crude palm oil. Let's see who's in the standings. Oh, now Tivia and M have climbed up and they are in the first 2 positions, followed by Yok Seong, Faris, and a new person, KCC. Next question. We are 2/3 through our quiz. Each cow fruit contains about 30 to 35% of oil. Is this true or false? Okay, we have 10 seconds for you to log in your answer. 5, 4, 3, 2, 1. The answer is true. Let's see if they remain. Okay, so Tivia is in first, followed by M, who has a streak of 10 correct answers in a row. KCC climbed to 3rd, followed by Yok Seong and Win Cheng. Next. What makes tocotrienol and tocopherol different in terms of their molecular structure? This was highlighted in the earlier talks. Is it the absence of carboxyl group, the absence of hydroxyl group, or the 2 double bonds or the 3 double bonds in the unique side chain? We have 5 more seconds to answer. Okay, so the correct answer is actually the 3 double bonds in the unique side chain, and 46 participants got this correct. Let's see who's in the standings. M has come up and is number 1, followed by Yeoxiong, Wincheng, Divya, and KCC. It's anyone's game right now. So next question. What is the amount of vitamin E in palm oil? 700 to 1100 ppm, 500 to 800 ppm, 600 to 1000 ppm, or 400 to 750 ppm? You've got 5 seconds left to answer. So the correct answer is 600 to 1000 ppm, and only 49 participants got this correct, but it's okay. Next, to see who's in the lead. So Yeoxiong has climbed up to first position, followed by M, KCC, Wincheng, and Divya. One interesting one is that somebody actually climbed up 24 places. Next question. Name the part where palm oil is extracted from. Is it the kernel, the shell, the mesocarp, or the fronds? About 10 seconds to answer. Where is it extracted from? 5 seconds, 3 seconds, time's up. Okay, so the answer is the mesocarp. Yeoxiong is still in first position, followed by M, Frederick. We have a new person who climbed up to third place, KCC, and Ferris in fifth. Next question. We are on our second last question. So the oil palm tree is native to which country? Brazil, West Africa, Papua New Guinea, or Malaysia? Which country is the oil palm tree native to? You have 5 seconds to answer. Okay, time's up. So the answer is actually West Africa, and 93 of you got it correct. Good job. Does Yeoxiong maintain? Okay, so Yeoxiong maintained in first, followed by N, Frederick, KCC, and Ferris. We are down to the next question, which is our last and final question. Name the application of palm oil. Is it detergent, in cosmetics, as food and health supplements, or all of the above? Final question, guys. Let's see if we can actually change the standings. Okay, 3, 2, 1. Time's up. The answer is all of the above, and most of you got it correct. So next, let's see who are the winners. In third place, we've got Frederick, followed by M in second place, and Yeoxiong in first place. Congratulations. Wow, you got 15 out of 15. Okay, so Yeoxiong, congratulations. You have won the RM300 e-gift voucher for Zalora. Don't worry if your name is not in here, as remember, we are giving away prizes to the top 30 winners. So please do wait until the end of the event to see if you have won yourself a prize, as we'll be showing the full list of winners then. Now on to Dr. Tan for the lucky draw. Another chance for you all to walk away with something.
Thank you, Diana. It was indeed nail-biting looking at the scoreboard. Everyone was being competitive to win something home. Once again, congratulations to all the Kahoot winners. If you didn't win during the Kahoot just now, fret not, because you still stand a chance to be our lucky draw winners today. We have 10 30 ringgits breadfruit e-gift cards up for grab by our lucky winners. So, as you can see on the screen here, how the lucky draw works is that each participant has been assigned with a lucky number. As you can see on the screen, we have all the participants' names projected on the screen right now. So we have upwards to more than 300 participants with here today. No, actually more than 500. So we have 584 participants with us here today. So how the lucky draw works is that we will have a random number generator that will generate 10 numbers randomly. And this is live. We will announce the corresponding lucky winners right away. So let's take a look at the 10 randomly generated numbers. Okay, seems like we have the 10 numbers. First, lucky winners. We have number 381. We have Hong Tian, from University of Nottingham, Malaysia. Congratulations. You have 30 ringgit to spend on Grab food. Next up, we have number 455. Let's see, 455, we have Noor Farah from Polytechnic Tun Syed Nasir Said. Ismail, congratulations, Farah. You won yourself a 30 ringgit food vouchers on Grab. Next up, we have 291. So on 291, we have Yud Histira from Xiamen University, Malaysia. Congratulations, you have 30 ringgit to spend on Grab food. Next up, we have 185, Muhammad Saifuddin from University Technology Mara. Congratulations. Next up, we have number 464. So 464, Stella from Swinburne University of Technology. Congratulations. You won 30 ringgit to spend on Grab food. Next up, we have number 298, Terry, again from Xiamen University, Malaysia. Congratulations. Next, we have number 81, Luke. Congratulations from Swinburne University of Technology. So for the third last lucky winners, number 480, we have Rosita from University Malaysia, Sabah. Congratulations. You won 30 ringgit to spend on Grab food. So next one, we have number 231, Iza from University Putra Malaysia. Congratulations to you. And for our final lucky winners, we have number 584. Oh, the last one, Siti Noor from Polytechnic Tun Syed Nasir Syed Ismail. Congratulations. You won 30 ringgit to spend on Grab food. So that's it, fellow participants. Congratulations again to all the 10 lucky draw winners. For the winners, our organizing team will be in touch with you on your prizes. So be sure to check your email for further details. All right, that's me at the end of my talk. On to you, Diana.
Thank you, Dr. Tan. Congratulations again to all lucky draw winners. All right, everyone. Now let's take a look at the full list of our Kahoot winners. Congratulations, and do enjoy your shopping or Grab food vouchers. To the Kahoot and lucky draw winners, the organizing committee will be in touch by email. On behalf of the organizing committee, we would like to thank you for sharing your time with us, as well as your active participation today. Do hang on, and the slide will come up in a while to show the full list of our Kahoot and lucky draw winners. We are just waiting for them to compile so that we ensure that we get it out to all the right winners. So I guess you guys won something in prize money, and not only like you guys also form some kind of knowledge. I hope that you guys can enjoy your vouchers, the one that you have won. So this is our full list of the Kahoot winners. So the first three were announced earlier. Fourth is KCC, Faris, Win Chang, Tivia, Mr. F, Chi, Lian, Lux, Aurelia, KF, Silane, Amanda, Steph, LKH, SW, and Sylvania, Libern, CS, Mika, Max, Jonathan here, Luke W, Is Afik, and my_B. Congratulations once again, and our organizing committee will reach out to you. So before we move on, we would like to invite all our participants here today to MPOC's upcoming event, which is the Virtual CEO Day at UTP 2021. It's hosted by MPOC and University Technology Petronas, whereby this event provides a platform for students to engage with the industry leaders in knowledge and experience sharing sessions on career opportunities and entering the workforce. Participants will have a chance to interact with industry stakeholders at the exhibition booth and enhance their employability by joining the resume writing masterclass. This event aims to cultivate a greater sense of pride for palm oil and its contributions to the economy and sustainability agenda. It is open to all university students in Malaysia. So do scan the QR code on the bottom corner to register. Exciting activities and prizes await you as well. Coming back to our event, we will now display the QR code on the screen. Please scan this QR code to record your attendance, as your e-certificates will be distributed based on your attendance record on this form only. So it is vital that you scan this code. If you have any technical difficulties, please refer to the chat box and our technical team will assist you. Also, do be reminded that today's presentations will all be available on MPOC's website, www.mpoc.org.my, for you to download later. Okay, so remember to scan this code, then you'll get your e-certificate. Distinguished guests, ladies and gentlemen, with that, we have come to the end of today's palm oil educational outreach webinar. I would like to say a huge thank you once again to all our speakers, Dr. Sam Nathan, Dr. Lee Chin Mei, Professor Dr. Lam Hon Lung, Dr. Siti Rahma, and Dr. Ruslan Abdullah for their highly informative and interesting talks. I would also like to thank the moderator, Dr. Ruslan Abdullah, for the smooth handling of the forum session. We hope that today's webinar was beneficial for everybody and that you all leave with a better understanding of Malaysia's palm oil industry. Have a nice day ahead and stay safe. Bye, everyone. Thank you.
Bye, everyone. Thank you. Thank you for joining us today.
Thank you.
Thank you all speakers. Thank you all the attendees.